3 hours or 4 hours of lecture with the AMOS demonstration for this topic, confirmatory factor analysis. So that is why we include this in the morning of day 2, because this afternoon we will have our structural equation modeling topic. Structural equation modeling is a combination of path analysis and confirmatory factor analysis. Okay, so to start, I would like to show to you the paper or the diagram as part of the publication of Churchill in 1979. If you look at the red arrow, I put a red arrow in step number 4. So factor analysis is included as part of the steps in the procedure for developing a better measure. So developing a better instrument, so better measures. So factor analysis in the 4th step is to purify measure. So factor analysis is really part of the development and validation of an instrument. So factor analysis is one of the tools in the classical approach of scale development. So in the literature of scale development, there are plenty of approaches. One of that is the classical approach, which includes the factor analysis. Some other approaches include the modern approach, such as the rush analysis, the IRT, or the item response theory. There are plenty in the literature. So those topics, including factor analysis, exploratory factor analysis, confirmatory factor analysis, rush analysis, and many more, belong to the topics included in the scale development and validation. So if we talk about factor analysis according to Churchill, some analysts like to perform factor analysis on the data before doing anything else in the hope of determining the number of dimensions underlying the constructs. So for example, if you have a new latent variable, you want to create your own questionnaire. You want to create your own scale or questionnaire because you feel that there is a need to develop a new questionnaire for the new variable. The first step is to uncover or discover a possible dimensions of your latent variable. So meaning you will discover a possible number of dimensions for your chosen variable. So it means that discovery is another contribution to your field. So if you discover, for example, that a certain latent variable has 6 dimensions, for example, it means that you are creating or you are developing a theory of your variable, indicating that your variable can be measured using 6 dimensions. So it is something that can contribute to your field of specialization. So in other words, factor analysis is very much useful for discovering possible dimensions of your chosen latent variable. These dimensions can only be discovered using or through the conduct of factor analysis. And that factor analysis is called exploratory factor analysis. Then if for example, after the discovery of possible dimensions for your chosen latent variable, you will publish that, then somebody can read your new publication. Another authors or another researchers might like to confirm your theory. So that's the time that this researcher will or might conduct another study, confirmatory factor analysis of your theory. So imagine that you have a theory, then somebody can read your newly published article. Then you will be cited because your newly published article shall be subjected for confirmatory factor analysis by another researchers. Okay, so we have two types of factor analysis. One is the exploratory. Your goal is to uncover possible dimensions of your chosen latent variable. Then later on, we can conduct confirmatory factor analysis of the results of your exploratory factor analysis. So there are the two have different purpose, different purposes, different utility. The first one, exploratory factor analysis, is used to discover factor structure or dimensions of your chosen variable. Then the other one, the confirmatory factor analysis, shall be used to confirm the result of your exploratory factor analysis. According to Bandalos in 2018, so this is the author, Bandalos, expert in instrument development. She has a book published in 1918 about this is about the instrument development. So factor analysis can be used to obtain evidence for the hypothesized structure of a scale. So obtain evidence for the hypothesized structure. So the hypothesized structure may be the result of the previous results of the previous analysis using exploratory factor analysis. So we can utilize factor analysis to obtain evidence, but we need to have a hypothesized structure of our scale, pangsukat scale. We can also generate theory about a construct. So we can generate a theory about your chosen latent variable. So in my example earlier, first you have a new latent variable, and using or with the help of exploratory factor analysis, you can generate a theory. The theory might be stating that your new variable can be measured using 5 or 4 dimensions. Of course, the dimensions shall be generated with the help of the factor analysis that I mentioned earlier. That kind of factor analysis is called exploratory factor analysis. Third, factor analysis can be used to verify theories about dimensionality. So after the generation of the theory in number 2, you can verify whether that theory still holds for a particular population of interest, whether that 4 dimensions, whether that 5 dimensions still hold for a particular population of interest. So number 3 is obviously a confirmatory. Number 2 is generation of theory, so it is exploratory. Then number 1, first is you have to hypothesize your theory, meaning to say, assuming that you have a new theory indicating that the scale or the variable consists of 4 dimensions, then you want to hypothesize that that particular scale consists of 4 dimensions, then you can still use the factor analysis. So in other words, the purpose of factor analysis technique is to help us understand the number of dimensions or the nature of the dimensions or factors underlying a set of variables or indicators or items. So marami kasi tayong pangalan, binigay yung pangalan sa mga items sa questionnaire. Pwedeng items, pwedeng indicators, pwedeng variables. So as I've said yesterday, items in the questionnaires can be observed. So all items in the questionnaire are observed variables, including the indicators of a certain latent variable. So if you want to know the title of the book, the source is Measurement Theory and Application for the Social Sciences. So Vandalos further stated that factor analytic studies address 3 primary questions. So how many factors are there? So in other words, if you have a new latent variable, so since it is new, since we label it as new variable, so we don't know how many factors are there. We don't know how many dimensions are there for that, how many dimensions are there in that particular new latent variable. So with the help of factor analysis, we can determine the number of factors. So after the determination of the number of factors using factor analysis, we can answer also the next question: what do these factors represent? So if in number 1 we can find several factors or several dimensions. Say for example, your new latent variable consists of 4 or 5 factors. Then with the help of factor analysis, we can be able to determine the label of every factor. So because the researcher in the beginning has no knowledge about how many factors, and the more the researcher has no knowledge about the name of every factor. So we can only determine the number of factors as well as the label of the factors after the conduct of the factor analysis. Then third, are these factors consistent with my theory? So we have three questions that can be addressed using factor analysis. So number 1 and 2 are exploratory. Exploratory in the sense that in the beginning, you don't know how many factors. You have no knowledge about the number of factors. And the more that you don't know the name of every factor. So it's totally exploratory. So therefore, it is called exploratory factor analysis. Number 3 is about consistency with an existing theory. So consistency of an existing theory, in other words, the result of number 1 and 2 is called a theory, and you want to know if that theory is still consistent. So in other words, number 3 is confirmatory in nature. Therefore, it is called confirmatory factor analysis. So number 1 and 2 is discovery. So meaning to say you want to discover possible factor structure of your new latent variable. So the result of number 1 and 2 is a theory. For example, again, if for example you have a new latent variable, it is time to think of a possible new latent variable nowadays, especially that our normal is new. We can think of a possible new latent variable, and of course you don't have knowledge about the number of factors or number of dimensions, and the more that you have no knowledge about the name of every dimension. Using factor analysis, using exploratory factor analysis, you can discover the number of factors. Then later on, you can determine also the name of every factor. Then after the conduct of 1 and 2, after the conduct of exploratory factor analysis, you can confirm using confirmatory factor analysis. There are plenty of research publication that utilize both exploratory and confirmatory in one research article. So the researcher gathered data twice. The first set of respondents shall be utilized to conduct the exploratory factor analysis. Then after the conduct of the exploratory factor analysis, the researcher would gather another set of data to be utilized for the confirmatory factor analysis. And after that, publish in the Scopus indexed journal. So when we talk about exploratory factor analysis, it is obvious that we can utilize it in the beginning stages of scale development. No idea about the number of dimensions. Of course, we don't know about the number of dimensions. We can only discover the number of dimensions after the conduct of the exploratory factor analysis. Then for the confirmatory factor analysis, the researcher may hypothesize a particular number of factors. So if, for example, there is an existing theory the existing theory was developed using exploratory factor analysis. So the result of the exploratory factor analysis shall be the requirement in conducting confirmatory. So in other words, you can or the researcher may hypothesize a particular number of factors that represent distinct aspects of a construct based on theory or prior research, and then write items to measure its factor. So, pwede din na ganon. Just like in our ongoing research with my colleague in LaSalle, what we are doing is we try to, or we aim to develop a questionnaire, a scale that can measure about students' readiness or student preference, digital preference. So it's about digital preference and digital readiness of among students. So we reviewed the literature. We conducted an intensive review of literature, and we found out that when we measure digitized preference of students, we found out that there are existing questionnaires. The existing questionnaires have varied dimensions. So we tried to analyze the result of our literature review, and we found out that we can classify we can summarize all these existing questionnaires into 8 dimensions. So the 8 dimensions shall be subjected for confirmatory factor analysis. So we wrote items in accordance, or we wrote items based on the results of the literature review. So using the 8 dimensions of digital preference among students, we wrote items for every dimension, and we come up with 35 items. Later on, I will use that data for our example. So the second one, the researcher already has a hypothesis about the number of factors underlying the items and about which items measure its factor. So there are 2 possibilities if we conduct confirmatory. The first one, you have to hypothesize a particular number of factors that represent distinct aspects of a construct. Dito papasok yung aming ginawa. So, yung aming ginawa ay ito, this part. The researcher may hypothesize a particular number of factors. The basis of our hypothesis na 8 dimensions ay nanggagaling sa literature review. Then we wrote our own items, drawn also from the literature, of course. And of course, some items were added, our own items, based on the culture of LaSalle. Okay. The other one, the second one, is the researcher already has the hypothesis about the number of factors. So of course, as I've said, this is a result of the previous exploratory factor analysis. So in other words, you have already an existing questionnaire that you want to confirm. So yun yung pangalawa. Okay. So the researcher may therefore ask questions such as, am I right about the number of factors? And do the items I wrote to measure factor A really do so? So do the items factor really do so? So that's these are the differences between the two, the exploratory and the other one is the confirmatory. So exploratory, the goal is to discover possible structure of your scale of your questionnaire. Confirmatory factor analysis is a confirmation of an existing factor structure, existing theory. So this is another opportunity for us researchers, opportunity in terms of the type of research that we can conduct in the future. We can generate a new theory using exploratory, or we can confirm an existing theory using confirmatory factor analysis. So these two types of factor analysis, I believe that these are underutilized in the graduate school of in the Philippines. Because based on my experience, ang palaging ginagamit ay comparison. We decide what variables, we decide the variables to be included in our research. Then we decide also the groups. Then our goal is to compare the groups. Then another research is correlational. So correlational meaning to say you identify a set of variables, then you want to test if one variable is correlated with the other variables. So it can be one variable versus another variable. So relationships between the two variables. Or it can be one variable, one outcome variable versus many predictor variables. So parang ganun lang ang uso natin. Wala tayong pagkakataon, depende sa university, wala tayong pagkakataon na i-expose to the different methodologies like this. Exploratory, pwede ka naman palang mag-invento ng questionnaire with the help of exploratory factor analysis. Pwede ka naman palang mag-publish ng paper na mag-utilize mo yung confirmatory factor analysis. Okay. So the next part of my presentation is about the comparison between observed variables and latent variables. Kasi nga, we will be we need to discuss this because our goal is to discuss confirmatory factor analysis. Then later on this afternoon is structural equation modeling. So for the observed variables, I mentioned this several times yesterday and this morning, that all items in the questionnaire are called observed variables. So that includes the demographic profile. So the way we measure a variable is multiple choice. So yun ang usual nating paraan to measure variable. For example, gender. Gender is a variable. Then the possible responses are provided. Then the respondents will just choose. Okay. Then sometimes the age also, we just provide a blank in the questionnaire asking the respondents to indicate their actual age. Then sometimes researchers um, prefer to provide the age bracket. For example, 10 to 19, 19 to 10 to 19, then 20 to 29, 30 to 39, and so on and so forth. So the researcher will just indicate the age bracket. Then sometimes, sometimes you include marital status, you include religious affiliation, you include socioeconomic status. So those belong to the demographic characteristics of the respondents. We call them observed variables. Then yesterday we discussed about latent variables. Latent variables, meaning to say we cannot measure directly, like for example, satisfaction and trust in this slide are examples of latent variables. So satisfaction consists of 4 statements or 4 items. Trust also has 4 items. Then all of these items are called indicators. So we can call them indicators, or we can call them items or statements. So both satisfaction and trust are again called latent variables. Then latent variables cannot be measured directly. So therefore, ang paraan ng researcher is to look for relevant indicators that can be used to measure the latent variable. Like, for example, satisfaction. Satisfaction is a latent variable. We cannot measure directly satisfaction. So in order to measure satisfaction, we need several indicators. For example, number 1, my choice to use this university was a wise one. That's one indicator of that variable. Then I am always delighted with this university service. That's another indicator. Then the last one, the 4th item, I am satisfied with this university. So these are the indicators under the latent variable. So we call satisfaction as a latent variable. We cannot measure directly. Okay. So there are 2 types of latent variable. The first one is the reflective latent variable. The indicators are expected to be highly correlated. So high correlation among the items. Then low correlation or not highly correlated if the items are expected to be not highly correlated, then we call that variable as formative. So to give you an example, I provided yesterday, for example, if we create a new scale, satisfaction with a meal, the indicators might be, I am satisfied with the meal, I feel full after the meal. So your items, these 2 items reflect the satisfaction with a meal measure and are expected to be highly correlated. Highly correlated because if you are satisfied with a meal, most likely you feel full after your meal. So your diagram looks like below. So satisfaction with a meal affects your level of satisfaction on every item. So your level of satisfaction on every item depends on your level of your overall level of satisfaction. If your overall level of satisfaction is high, the probability that your level of satisfaction on every item is high also. So your level of satisfaction on every item depends on your overall level of satisfaction. So when we say your level of satisfaction on number one item or first item depends on your overall level of satisfaction. So yun yung ibig sabihin. So kung sasagot ka sa pangalawa item, so your rating on the second item depends on your overall level of satisfaction. That is called reflective latent variable. Okay, so let us create or develop another same questionnaire, but in a formative way. So what are the items? So I am satisfied with main course, then I am satisfied with a dessert. So the two items are not necessarily correlated. Not necessarily correlated. I wrote here the main course and dessert make up the meal. They are part of the same meal, but their satisfaction indicators are not expected to be highly correlated with each other. The reason is that some people may like the main course very much and not like the dessert. Conversely, other people may be vegetarians and hate the main course, but may like the dessert very much. So your modeling approach looks like this. Your level of satisfaction depends on the main course and the dessert. In short, your level of satisfaction with a meal depends on the food that you have eaten. Depends on the food that is being served. Okay, so the two variables, we measure the same thing, but we measure differently. So reflective, if we summarize, reflective, the items are highly correlated. Then the latent variable, the LV, latent variable causes the indicators. That's reflective. Expect that the items are highly correlated. Then for the formative latent variable, expect that the items are not highly correlated. Then take note of the direction of the arrows. The LV, latent variable LV, satisfaction with a meal is caused by the indicators. Meaning to say the LV depends on the indicators. Dito sa kabila, yung indicators depends on the latent variable. Okay, pabaliktad. So, parehas lang tayong nag-measure ng satisfaction with a meal, pero iba-ibang paraan sa pag-measure. Okay? So another example to differentiate reflective latent variable and formative latent variable. So for reflective in this example, drunkenness, if we measure drunkenness in a reflective way, so the items might be dizziness, speech blurred, slow reactions. So yung kung lasing na ang tao, these are the indicators. Speech blurred, slow reactions, diciness. And these items, these indicators are expected to be highly correlated. Then we observe this diciness, speech blurred, and slow reactions because the person is already drunk. Okay, but if we measure it formatively, it is a different situation, different methodology. You are drunk because because of the wine, or because of the liquor, or because of beer. So take note, we use or. We use or. So meaning to say any of the three. So not necessarily that you consume all of this. Not necessarily that the person become drunk because of the three. May possibility naman ng zero amount of beer, zero amount of wine, pero maraming liquor ang iniinom niya. Malalasing pa rin. So not necessarily that the three indicators are highly correlated. So your being drunk depends on whether uminom siya ng wine, uminom siya ng liquor or beer. So two approaches on how to measure variables, latent variables. So during the instrument development, you have to consider also these types of variables. So very important ang pag-measure ng variable. Kasi garbage in, garbage out. Kung mali ang pag-measure mo sa mga variables mo, we cannot expect a correct findings of our study. We really start from the very beginning. Each step is very important. From step 1 up to the end, each step is very important. From gathering of data or from development of the instrument, in fact, from review of literature, from the formulation of framework, formulation of research hypothesis, research question, up to the development of the instrument, up to the data analysis. So kung may mali ka dyan, may problema ang findings mo. Okay, so another example, reflective latent variable. So these are highly correlated. So the same ang goal mo, you have to measure the satisfaction of customer satisfaction of the services in a hotel. So I feel comfortable in this hotel. I am happy to stay in this hotel. So I recommend this hotel to others. So expect that obviously yung tatlo na yan, highly correlated yan. Kung comfortable tayo sa hotel, of course, we will be happy when we stay the hotel. Then most likely, we recommend the hotel to others, to our friends, to our colleagues. Correlated talaga yung mga items. Whereas dito sa kabila, the room is well equipped. So may possibility naman na maganda yung rooms, pero ang personnel nila may problema. Okay? So yung mga indicators dito ay hindi sila correlated. Okay? So papasok na yung confirmatory factor analysis. Because assuming that we have already the theory, we have already the hypothesis that a certain instrument has a number of dimensions, and we know already the specific dimensions. So yun yung goal ng confirmatory factor analysis. So the objective of CFA is to test whether the data fit a hypothesized model. The hypothesized model, of course, CFA model. So the hypothesized model is based on theory and or previous analytic research. Then if we trace the history of confirmatory factor analysis, it was developed in 1969. So it's already 51 years old. 51 years old CFA. Pero magtataka tayo bakit pagdating na sa mga universities, bihira lang yung schools, bihira lang yung university sa Philippines na nag-discuss about CFA. Kaya napansin ko bihira lang din yung journals, especially managed by Philippine universities. Bihira lang yung mayroong confirmatory factor analysis. So there are the basic steps in conducting CFA. First one is, of course, discuss the theory to be confirmed. Okay, so after that, after the discussion of the theory, of course, when you discuss the theory, talagang intensive discussion. Kasi theory yan eh. Then prepare the survey questionnaire. For example, if your theory states that teaching performance can be measured using 4 dimensions: planning and preparation, classroom environment, instruction, and professional responsibility. So may theory na ganon, na yung teaching performance can be measured using 4 dimensions. Again, planning and preparation, classroom environment, instruction, and professional responsibility. That is an example of a theory. Then next is to prepare the survey questionnaire. Okay. Then after that, you gather the data, then you can draw the CFA model. The drawing or the diagram can be, kasi mas maganda yung AMOS kasi built-in yung pwede kang mag-drawing doon ng model. Then after that, you present the following. So in other words, your manuscript can contain the following: diagram with estimates, goodness of fit and fit indices, convergent validity, discriminant validity, and reliability coefficients. So for today's discussion about CFA, we will use AMOS. Yesterday, we utilized the WAR-PLS to produce the convergent validity, discriminant, and reliability coefficients. At this time, para sa confirmatory factor analysis talaga, we will utilize the AMOS. Kasi yung AMOS, para talaga yan sa SEM at saka confirmatory factor analysis. Example 1. The CFA model to be confirmed was used by Aragon in 2004. He called it patient satisfaction scale. It has 3 subscales, namely satisfaction with physician service, satisfaction with nursing service, then satisfaction with waiting time. These are the dimensions, the 3 dimensions involved in this questionnaire. in this scale, satisfaction scale. So the scale has a total of 8 indicators. So the indicators for satisfaction with physician service include the following: takes problem seriously, concern for comfort, explains test and treatment. So in other words, so that we can measure the satisfaction with physician service, we need the 3 items. These are the items that shall be included in the questionnaire, whether you will use a, say for example, 5-point response option or 4-point response option. Okay, whether they are satisfied of this services, of these indicators. Second, there are 3 indicators for nursing. So takes problem seriously, again, attentive, then technical skill. Then the third variable, which is waiting time. So waiting time for the medical doctor, then explain delays. Okay, so I can relate this because my my doctor is in the UST hospital. I regularly asked for laboratory exam twice a year kasi may ano naman mayroon namang healthcare free. Kaya pwede tayong magpa lab test regularly. Ginawa ko, instead na once a year, ginawa ko twice a year. Free naman So, for example, yung mga cholesterol, yung lahat na about sa blood test. So, libre naman yon. So, I took advantage. So, maliban na lang ngayon dahil pandemic. So, hindi ako nakapunta last March dapat. Last week ng March. So, hindi ako nakapag lab test. So, kung pupunta, pag mayroon ng laboratory results, pupunta ka sa physician mo or sa doctor mo, sa medical doctor, para i-advise ka kung halimbawa may problema sa blood mo, so resitahan ka ng mga gamot or advise ka na ganito ang kakainin mo, something like that. So however, dahil sa dami ng pasyente doon sa kanyang clinic, maghihintay ka. So mayroong waiting time. Kaya I know that there is really a waiting time when it comes to itong questionnaire ni Aragon is about emergency services of the hospital. So it includes the medical doctor, the nurses, and waiting time. Yung example ko ay ano naman yun, hindi naman yun emergency. Pero mayroon pa ring waiting time. Okay, so yan, tatlong dimensions just for discussion purposes. So if we compare this questionnaire with our practice in the university, tayo ang dami ng ating items. Sa kanya ay itong publication na to ay 8 pala. 8 items or 8 indicators in order to measure the 3 dimensions. So 8 indicators, nakapag-conduct na siya ng confirmatory factor analysis. So the theory states that the 3 dimensions or the 3 subscales are correlated. The correlated subscales and the respective indicators are depicted in the diagram below. So ito ay ako na ang gumawa nito using AMOS. So this is our diagram with respect to the theory. Sabi kasi sa theory, the 3 subscales, ang subscales are satisfaction with physician service, satisfaction with waiting time, and satisfaction with nursing service. according to the theory, these three dimensions or these three subscales are correlated. So mayroon tayong double-headed arrows across the three subscales, indicating that the three subscales are correlated. Okay? Then we have also boxes. The boxes, or each box, represents the indicator. For example, C3, C4, C5. The C3, C4, C5, this corresponds to takes problem seriously, concern for comfort, explains test, and treatment. So if, for example, there are no missing values, meaning to say all patients provide their responses on all items, meaning no missing value, so we can utilize this diagram. Okay, so we have the mean, meaning to say that every latent variable has a mean. There is also a variance. Okay, so this mean one, variance one, correspond to the mean and variance of the first subscale. This mean 2 and variance 2 correspond to the mean and variance of the second subscale. Okay, and so on and so forth. So the other with missing values, dahil sa missing values, so pwede nating i-standardize yung result so that the mean is 0 and the variance can be computed based on the data. So ang mean here is 0 and the variance shall be computed based on the data. Okay. So this is the sample result with coefficient. So the 0.77 represents the correlation between physician service and nursing service. 0.85, this represents the correlation between waiting time and nursing service. So ganun ang gagawin. Kasi di ba ang sabi sa theory, the three subscales or the three dimensions are correlated. So dapat i-correlate mo din yan. So AMOS is user-friendly. The diagram, in the diagram, the correlation coefficients are provided. So kung successful yung computation, the correlations shall be reflected in the diagram like this. The same also with the items. Yung 0.92, 0.95, 0.90, these are indicator loadings. Okay. 0.89, 0.85, these are indicator loadings. Okay. Then yung E1, E2, E3, these are errors in measurement. We cannot avoid errors in measurement dahil nung binigay natin yung questionnaire, perception lang naman yung kanyang ibibigay, hindi naman yung 100% error-free. So mayroon talagang error in measurement. Meaning to say, your instrument, your questionnaire being used as an instrument in order to measure, hindi siya error-free. So there are really errors in measuring every indicator rather. Okay, so for this example, the first step is to draw the diagram, then fit your data with the diagram, with the model. Then ilalagay natin lahat ng goodness of fit and fit indices, including the chi-square, the p-value, the RMSEA, is RMR, NFI, CFI, and so on and so forth. Marami yun kahapon, di ba? Then, of course, we can utilize the criteria provided by Engel and colleagues in 2003. Yung table na the table that we discussed yesterday. So for this criteria column, P, the value of P should be greater than 0.05. So since the P value of our result is not okay, so I put not okay. Dahil ang P value nito ay less than 0.05. So hindi siya okay. Then in terms of chi-square divided by DF, sabi doon sa paper nila ni Engel, acceptable if between 2 and 3. So acceptable fit. Then in terms of root mean square error approximation, sabi doon sa paper nila, acceptable if between greater than 0.05 and 0.08. So acceptable. So ganun lang ang gagawin natin. So in other words, out of the many fit indices, p-value lang ang hindi okay. So ang importante, mayroon kang okay, mayroong acceptable, or good fit. These are just the evidences showing that the data and model, the theory and model are consistent. Okay, goodness of fit. So ito yung binanggit kong goodness of fit and fit indices. Of course, you have i-provide naman natin yung kopya nito. So it is not an issue. So if, for example, mayroon naman tayong chat group, in case you want the copy of this article, hindi kayo satisfied sa table, for this table, gusto niyo yung kopya ng buong article, so I can provide also. So we can proceed to the construction of instrument or the validity. Yesterday I presented the content validity. Then at this time we will review, because we will have hands-on later or demonstration about the use of AMOS. So it's already 10 o'clock. Okay, so at this time we will review the convergent and discriminant, as well as the Cronbach alpha and composite reliability. So yesterday we utilized the definition of Koch, this definition. So we can easily understand his definition, meaning to say definition for layman. So this portion, okay. So according to Koch in 2015, research instrument has good convergent validity if the indicators associated with the latent variable are understood by the respondents in the same way as they were intended by the writer of the questionnaire. So how do you know that the respondents and the writers have the same understanding about the statements or the indicators? So with the help of the statistics, we can check the indicator loadings as discussed yesterday. The indicator loadings should be statistically significant. Then the p-value should be equal to or greater than the cutoff provided by Hare, which is 0.50. So in other words, we want that our p-value is 0.50 or higher. So according to Hare. Then aside from that, we need also to get the average variance extracted Our average variance extracted as discussed yesterday is still 0.50. So 0.50 or higher according to Fornell and Larker in 1981. Okay, so in other words, we look at the indicator or item loadings, the p-value, we look at the p-value, the indicator loading should be statistically significant. The value of the indicator loading should not be less than 0.5. Okay, we can utilize the suggestion of Hare and colleagues. Then the average variance extracted should not be below 0.50. It should be 0.50 or higher. So for our example number 1, so I have here the indicator loadings. So the indicator loadings are provided, summarized. The indicator loadings were taken from the result of the AMOS. So all of the indicator loadings, the loadings of the 8 indicators are all greater than 0.50. So there's no problem. The average variance extracted also are greater than 0.50. So in short, we have no problem about the indicator loadings and the average variance extracted. So in other words, if you have that results, it means that your variables such as physician service, nursing service, and waiting time have convergent validity. Another validity, type of validity to be presented when we conduct confirmatory factor analysis is the discriminant validity. So the discriminant validity, according to CAC in 2015, so there is an instrument has discriminant validity if the items of the latent variable are not confused by the respondents in terms of their meaning with the indicators associated with the other latent variables. So no confusion involved. So if the respondents are not confused about the meaning of the indicators associated with the other latent variables, then your instrument has discriminant validity. So there are 2 approaches. The first, as discussed yesterday, we have the Fornell and Larker. The other one is the Fcmt. So yan yung mga latest, yung 2015 version recommended by Henseler and his colleagues in 2015. Yan yung latest. So pag ang Fcmt ay 0.85 or below 0.85, so it is called best discriminant validity kasi mas stricto yung cut-off na yung 0.85. Then kapag less than 0.90, good. Medyo maluwag yung cut-off na to. So kaya sinabi dito sa paper nila ni Henseler na liberal discriminant validity. Okay? So 0.85 or 0.90. So that there is discriminant validity. Or you can utilize the approach of Fornell and Larker in 1981, stating that the square root of the average variance extracted should be greater than the correlations among the variables. among the latent variables or among the constructs. So this is the example of result of the discriminant validity based on Fornell and Larker in 1981. So yung nasa diagonal, square root of average variance extracted ito. Tapos yung nasa off diagonal, yan ang correlations among the variables. Okay, so another one is the HTMT. So the HTMT tell us that the variables such as SP, SWT, NS have HTMT of less than 0.85. These values indicating that the variables have better or best discriminant validity. Best discriminant validity kasi less than 0.85. Good discriminant validity kung 0.90 or below. Okay. So after the presentation of the convergent validity and discriminant validity, you can present the composite reliability. So as discussed yesterday, the composite reliability and Cronbach alpha have cut off. So for example, for the Cronbach alpha, 0.7 or higher. So you have these articles. Then for the for a more relaxed criterion, as discussed yesterday, the composite reliability is always higher than the Cronbach alpha. So sabi dito sa more relaxed criterion, one of the two coefficients should be equal to or greater than 0.7. This typically applies to the composite reliability coefficient, which is usually the higher of the two. So again, the composite reliability is always higher than the Cronbach alpha. So sabi dito, one of the two coefficients should be equal to or greater than 0.7. So kaya yung 0.7 dito pertains to the composite reliability. Then a more relaxed criterion, 0.6 or higher. The Cronbach alpha should be 0.6 or higher. So sa bawat criterion na gagamitin natin, dapat specify mo kung ano ang criterion. Ano ang cutoff. Research lang yan kasi available na yan eh. So in my lecture, I always provide the criterion. So after that, after the presentation of the convergent, discriminant, and reliability, you can, of course, you can present the yes, reliability coefficients. Present mo, including the number of items. So in our example, the waiting time consists of 2. So this is wrong. So this is dapat ito ay 2 lang. Okay. So in our example, the waiting time consists only of 2 items. So the reliability is 0.86. So yung practice natin na padamihan, very long instrument, hindi na kailangan. Kasi pwede na naman siyang reliable kahit dalawa lang. Kagaya nito, for this example, the reliability coefficient is 0.86. Although there are only 2 items. Kasi yung iba, redundant na yung mga items. Nursing service, 3 lang, pero ang reliability is 0.948. Physician service, 3 items lang, pero ang reliability is 0.948. But remember that during our discussion yesterday, kahit na reliable yung instrument, there is a possibility na hindi siya valid. Okay, so take note of that. Kailangan valid and reliable. Okay, so second example. So this is another example showing to you that confirmatory factor analysis is really very important, and you can produce this type of research then publish. So for example, our ongoing study, we attempted to develop a scale that measures the students' digital preferences and readiness on online pedagogy. So as I mentioned earlier, the name of the questionnaire is Digital Preferences and Readiness on Online Pedagogy, Online Teaching Learning. Okay, so I call it Students' Digital Preferences and Readiness Scale on Online Teaching. So we conducted an intensive review of literature. Then we obtained 8 different factors. The 8 factors corresponding to the items are as follows. So first, we have the technical competencies. We have the social interaction with peers, social interaction with instructor, then self-directed learning. Then we have the motivation, we have the learning preference, importance to online learning process, then communication skills. These are the results of our review. We found out that digital preferences and readiness can be measured using 8 dimensions. Then for every dimension, we provide a number of indicators. So in this example, I put, for example, technical competencies. So we have the TC14, TC23, TC29. Kasi nga, nirarambol namin pagbigay sa mga students. So when we conducted or when we administered the questionnaire, nakarambol yung mga items. Hindi alam ng students na yung item na yun ay para sa technical competencies. The students or the respondents did not know that that item is about motivation. Basta binigay lang namin yung mga items, then we listed all the items in the questionnaire. Then we did not inform the respondents that that item is for technical competency, for example. So basta lang, ramble lang. So there are 38 items or 45 items in the questionnaire, pero yung iba hindi na para sa ibang research yun. Kaya actually the number of items for this questionnaire is only 35. Pero yung napansin nyo, yung mga number or item number ay umabot sa 45. So mayroong 44 dahil mayroon kaming sinamang mga items na not indicators of this questionnaire para sa ibang research. Okay, so sample items, for example, social interaction with peers. So we have this. I am confident interacting with other students in an online environment. Number 2, we have technical competencies. I feel comfortable using computers. Then we utilize the 4-point response option. We avoid the middle value, the neutral. We avoid that. We always avoid the neutral or no comment, yung mga ganun. Kasi ang students as respondents, they always play safe. Para safe sila, pipiliin nila yung middle value, hindi na nila babasahin. So, pag ganito, tinanggal na namin yung middle value, kaya 4-point response option kami. So, the model to be confirmed is basically consists of 35 items, consists of 8 interrelated. So, take note of the theory. The theory states that the 8 variables are interrelated. So 8 factors. We call them 8 factors. Ongoing pa lang yan. So I cannot provide you the paper kasi nasa ano pa kami, data analysis stage. We already administered the questionnaire and we already collected the data. I think more than 800 ang sample. It's already more than enough for the confirmatory factor analysis. So yun yung gagamitin ko yata mamaya sa ating hands-on. Okay, so for a real research article, the CFA model should be discussed intensively. So discuss intensively meaning to say you, for example, you include the definition of the factors as well as the sources of the factors, and the relationships among the variables should be discussed also with complete references. Then a diagram that represents the CFA model can also be presented. So these are the initial. So we call it model 1. So the model 1, again, there are 8 dimensions. TC stands for technical competencies. Then peer, ano ba yung iba doon? So social interaction with peers. So yan yung SP. Instructor interaction. So the instruction, social interaction with instructor is I. Yan. And so on and so forth. Then yung oval, the ovals represent the factors. So there are 8 factors. Then for every factor, there are items. Okay, there are items for every factor. The items are represented by boxes. Okay, so dahil sa dami ng factors mo, 8, kung i-drawing mo yung, i-connect mo yung bawat oval, kukonek mo ng double-headed arrow, ganyan ang mangyayari. Kaya medyo complex tingnan. Okay? Pero ang importante dito is that I noted here at the left. So in the diagram, the coefficients in the double-headed arrows represent correlations among the 8 factors. So sa ating result kahapon sa AMOS in the afternoon, sa bawat numero na nandyan, mayroong corresponding p-value, di ba? So we found out that all correlation coefficients are statistically significant. So the values are less than 0.001. So we are very happy of that. Kasi ang cut-off natin, 0.05 lang naman. So mas mababa pa kaysa 0.05. In fact, less than 0.001. Okay? So in other words, all factors are correlated. So na-confirm yung theory na yung 8 factors are correlated. Then the coefficients in the one-headed arrow, yung for every latent variable, mayroon siyang corresponding boxes, di ba? Kada bawat latent variable, mayroon siyang mga items, yung box. So the coefficients in the one-headed arrow path from the factors to the items or boxes are called indicator loadings. So nilagyan ko naman ng label para friendly naman yung slides. So all are statistically significant also. So in other words, in terms of statistical significance, acceptable yung mga items. Kaso, kailangan pa nating sa indicator loadings discussion, hindi lang p-value ang titingnan. We need also the magnitude or the actual value, kung 0.5 or higher ba. Okay? So, notice that in confirmatory factor analysis, we don't need to compute the cross-loading. Kasi ang cross-loading, for example, TC, ang naka-load dyan ay puro items lang niya. So, walang pagkakataon na yung mga items natin ay nag-connect sa other factors. So, indicating na we force the items, we force the cross-loadings of every, we force the cross-loadings to be 0. Kasi wala siyang pagkakataon na nag-connect sa other dimensions. Okay? So, ang ibig kong sabihin, ganito. I will put a line. For example, TC14, yung isa sa mga items ng technical competencies. Naka-load lang siya sa TC. Wala siyang pagkakataon na nag-load sa other factors. Walang ganyan. Sorry, dapat red. So, walang line from SP, for example, going to TC14. Kapag ganyan, ang ibig sabihin may cross-load. Pero, napansin nyo, ang bawat item ay para lang talaga sa target variable or target dimension. No cross-loading. Kaya hindi na ako nagbanggit ng cross-loading kanina. Okay? So, there is a note here. In the actual paper, a correlation matrix should be presented. Then at the bottom of the goodness of fit statistics, or at the bottom of the diagram, are the goodness of fit statistics. Pansin nyo, we have the chi-square, we have the p-value, we have the root mean square error approximation, the GFI, CFI, and so on and so forth. So, ang tanong dito, natapos na natin yung computation for the 8 dimensions of digital preference and readiness. Na-draw na natin, then na-compute na. We found out na lahat ng indicators ay significant. Lahat ng correlations are significant also. Ang tanong, yan na ba ang ating final? So, ang ibig sabihin na confirm mo na ba ang theory? So, hindi pa. So, kailangan pa natin ng Model 2. So, the Model 2 is medyo malinis dahil tinanggal natin ang mga items na mababa sa 0.50 ang indicator loadings. Okay, napansin nyo. So, kukunti na lang yung mga items. So, hindi na umabot ng 35 yan kasi may mga items na tanggal. And aside from that, yung ating goodness of fit ay nag-improve. Okay, for example, the root mean square error approximation ay naging 0.057 na. Then, yung ating NFI ay 0.899. So, kanina, ang NFI natin, hindi pala na-record dito. Kanina, ang ating root mean square error approximation is 0.06. Pasok na yan. Pero nung tinanggal natin ang lahat ng mga items na less than 0.50, yung root mean square error approximation ay naging 0.057. Okay, so ang gagawin natin, we create a table for the goodness of fit and fit indices of the two models. So ang goodness of fit na tinutukoy dyan ay yung chi-square p-value. Yan yung goodness of fit. Tapos yung mga fit indices, yan yung root mean square error approximation, SR-MR, NFI, and so on and so forth. Okay, for the model 1, ibig sabihin model 1 yung wala tayong tinanggal na mga items. Ang kanyang chi-square ay 2,222, malaki. Versus doon sa model 2, na tinanggalan na natin ng mga items, medyo lumiit na yung kanyang chi-square. So, as discussed earlier, or yesterday, a model with a smaller chi-square is a better model. Okay, so, kaya nilagay dito, model 2 has the smaller chi-square. Hence, it is better than model 1. Okay, yun yung remarks. So, we can choose model 2 when it comes to chi-square. So, in terms of p-value, we cannot determine which one is better because parehas lang naman silang 0.000, tatlong zero. So, we cannot determine in terms of p-value. In terms of chi-square divided by degrees of freedom, model 2 is better. But the two are within the acceptable range. Okay, kaya nilagyan natin dito ng both models within the acceptable range. In terms of root mean square error approximation, both values are within the acceptable range. Kaya we have this remark. In terms of SR-MR, both also are within the acceptable range, but model 2 has a better fit than model 1 because model 2 is smaller than model 1. Then lahat ng NFI, GFI, AGFI, CFI, the larger, the better. The closer to 1, the better. Kaya panay dito ang remarks, model 2 has a better fit than model 1. Okay. Dito naman sa AIC, CEIC, and ECVI, ang best model naman, ang better model, yung model na mas mababa ang value ng AIC, CEIC, at saka ECVI. So that is why model 2 is still the preference. Okay? So take note that model 2, yung model 2 na yan ay correlated yung mga factors, significant ang mga indicators. At the same time, the indicators are greater than 0.50. So all indicators na below 0.50 ay tinanggal. Okay. So after this, ibig sabihin yung model 1 mo ay hindi siya acceptable. So you can propose model 2. So the model 2, of course, includes the acceptable items, of course. Then aside from that, yung convergent validity statistics are also included in the decision. Kasi dapat ang average variance extracted ay greater than 0.50. Kapag isama natin lahat ng mga items, yung 35, hindi umabot ng 0.50 or higher yung ating average variance extracted. That is also another, this is also another criterion of deciding which items to be removed. Okay, so for example, we have the technical competencies. Lahat ng mga indicator loadings of the 5 items are within the acceptable range, then the average variance extracted ay 0.5 or higher. In terms of social interaction with peers, the 5 items, pasok yung kanilang indicator loadings, then the average variance extracted is greater than 0.50. In terms of social interaction with instructor, all the 5 are acceptable. So acceptable in terms of indicator loadings as well as the average variance extracted. So in my presentation, I only provide the 3 variables, but later on during the demo using AMOS, ay kasama na lahat. Okay, so after that, you can present also the discriminant validity based on Fornell and Larker, 1981. Lahat ng nasa diagonal ay square root of the average variance extracted. Meaning to say, if you get the square root of 0.565, automatic ilalagay ng software dito. Square root of 0.526, ilalagay niya ang result dito. So lahat ng nasa diagonal, yan ay square root of the average variance extracted. Now, this square root should be compared to the correlation coefficients. The values with asterisk are correlation coefficients among the variables. So it means that the questionnaire have discriminant validity. So another one is the discriminant validity based on HTMT. So yung mga values dito are values of HTMT. So based on our discussion yesterday and this morning, kapag less than 0.85, ibig sabihin best discriminant validity. So pasok siya sa best kasi wala naman siyang greater than 0.85. So best discriminant validity yung questionnaire na yan. Okay. So after that, we present the composite reliability as well as the correlation coefficient. Kasi, di ba, the first thing that we need to confirm is that the 8 dimensions are correlated. So, yun yung unang i-confirm mo eh. So, based on the results, lahat ay correlated. Lahat ng mayroong asterisk, yan ang nag-represent ng correlations. So, indicating that the 8 dimensions are statistically correlated. Then, in terms of reliability, all 8 dimensions are reliable. So if we use the more relaxed criterion, pasok itong IM at saka CO. Although mababa siya kasi 0.63, 0.68. So mababa siya in terms of composite reliability. So mayroon naman tayong reference kagaya nito sa baba, CR meaning to say composite reliability of 0.6 or higher is acceptable according to Nunnally and Bernstein in 1994. Okay, so these are the things that we can report. If we summarize, first, we can report we can include in the paper the discussion of the theory, Then after the discussion of the theory, of course, you gather the data. You prepare the questionnaire, then gather the data. Then after the gathering of data, we conduct the CFA. Then the results of the analysis shall be summarized. Like, for example, you should provide a table for the correlation coefficients. Kasi ang i-confirm mo ay dapat ang 8 dimensions, according to the theory, 8 dimensions are correlated. So you should produce a correlation matrix like this, showing that the 8 dimensions are correlated. Then, if it is not correlated, then so be it. So just be honest that sabihin mo lang na yung, for example, mayroong dalawang variables na hindi correlated, so just describe. Present it honestly. Then after the presentation of the correlation matrix, so you should provide the goodness of fit. So, pero sa akin, for my bias, I will start the presentation of the goodness of fit. So yun ang pinaka-importante. So dapat yung model and data are consistent. So I will start the presentation of the goodness of fit, then compare the model 1 and model 2. Then after the presentation of the goodness of fit, I can proceed to the discriminant validity, results of the discriminant validity, convergent validity. Then after the presentation of the convergent and discriminant validity, I will proceed to the correlations. So all of that are evidences of your theory, of the theory that is being confirmed. So yan, isang article na yan, isang research article publishable in Scopus journal. Okay, so after this, I will show to you the procedure on how to conduct. So siguro how to conduct using CFA using AMOS. So 30 minutes break, pero kung okay sa inyo, I can proceed to the AMOS. So kung okay sa inyo. So are you okay na i-skip natin yung 30 minutes break, then I can proceed to the hands-on or to the demonstration using AMOS. Siguro mga ano lang, mga wala pang 1 hour, tatapos na natin so that we can dismiss early. Okay sa inyo? Are you comfortable?
Okay po, sir.
Yes, sir.
Yes, sir. No
Okay.
worries po.
Okay, no worries. So we skip the 30-minute break, so I can proceed to the demonstration of AMOS. Okay, so I go back to the screen. Okay, so I will open my my AMOS. So I think ito yung AMOS natin kahapon. Okay, so we need AMOS bago. So I will open instead my drawing. CFA. Okay, so without missing. So yan yung ibig sabihin. Okay, so first I will open also the data set. So I think the data set, I forgot to put it dataset ko ay nasa different folder. Male patients, this one. Manigurado lang ako ha, ilagay ko sa PUP, baka makalimutan. CFA. Oh, mayroon pala. Mayroon na pala ako dito. Okay, so I will open my SPSS. So input of input data can be raw data like yesterday na yung variables natin ay nasa columns. So dito naman sa AMOS, pwede siyang tumatanggap ng covariance matrix na. So meaning to say, ito yung mga, di ba mayroon tayong list of variables, like for example, explains, test, and treatment para sa medical doctor or physician service, concern for comfort, takes problem seriously. So yung C3, C4, C5, ito yung mga variables under physician service. Then we have the waiting time. So the waiting time here, waiting time for the MD, explain delays. So these are the items under waiting time. Then we have the, say for example, technical skill, attentive. Then we have takes problem seriously. These are items under nursing service. Okay. So nursing service, pwede naman natin ito ay palitan ng pangalan. For example, pwede mong gawan ng NS para ma-memorize mo kung ano yung items under nursing service. For example, ito ay nursing service 1. Pwede natin gawin ganon. Nursing service 2. Parang ganon. Nursing service 3. So these are the items under nursing service. Letter N stands for nursing, then S service. So nursing service, technical skill, attentive, and takes problem seriously. So for the medical doctor or the satisfaction with physician, di ba mayroon tayong physician service 1, pwede natin palitan yan. Physician service 2, I hope you are a user of SPSS. Physician service 3. Okay? So ibig sabihin, yung takes problem seriously, this is the first item under physician service. Concern for comfort, this is the item for the physician service. Then explains test and treatment, third item under physician service. Then for the waiting time for MD, so halimbawa waiting time MT 1, then we have MT W waiting time 2. Yan. WT1 stands for waiting time, item number 1. So waiting time for MD. WT2 stands for the second item under waiting time. Waiting time explains or explain delays. Okay? Waiting time. Okay, so yung pangalawa, yung itong worth the money and would recommend, different item ito para ito sa overall satisfaction. 1, overall satisfaction 2. So yan yung pag-prepare ng data. So I changed the variable name para aware kayo na dapat kapag nag data analysis tayo, dapat yung mga items natin ay nakakabit doon sa variable name. For example, physician service, PS. Another example, waiting time, so we can use WT. We have the nursing service, we can use NS. Okay? Then we have the overall satisfaction, OS. Okay? So dahil binago natin yan, so ang makikita natin dito sa data view ay yung PS1, PS2, PS3 na. Pero yung ating raw data, ang ating data input rather, our input, of course, pwede siyang covariance. So meaning to say, the values in the matrix are covariance. Covariance. Okay, kung covariance ang gagamitin natin, dapat i-indicate din natin ang mean. Okay? So in other words, if we conduct confirmatory factor analysis, our input data can be a summarized data like this. Then you can include this in the appendix of the manuscript. Diba? Kasi konti na lang. Nakasummarize na eh. So nakasummarize na, meaning to say, summary data na yan. So covariance can be one possible matrix. Pwede yan. Another one is correlation. Pwede mo correlation ang ilagay mo dito. Correlation among the variables. But you need to add another row for the standard deviation. Kung correlation ang gagamitin mo, dapat mayroon kang correlation dito. So, no, standard deviation, sorry. Kasi nga, correlation ito. Kapag correlation dito, ibig sabihin yung mga numbers nandyan ay correlations, add standard deviation here. SD. Okay? For covariance, if you use covariance data, these are covariance data, then you don't need to input the standard deviation. Mean lang. Okay? So, alternatively, of course, yung raw data. Yung raw data, yung actual na data about PS3, actual data about PS2, and so on and so forth. So, kung mahirapan kayong gumawa ng matrix like this, do not use a summary data. Use the raw. Yung kagaya kahapon ng raw data natin ay nakalagay yung actual rating for every respondent. Okay? So if you have 500 respondent, you will occupy 500 rows also. Kung raw data. So ang kagandahan sa confirmatory factor analysis and structural equation modeling in AMOS is that we can present the matrix, covariance matrix or the correlation matrix. So ilagay mo lang ang sample size sa first row here. Then the rest, correlation or covariance matrix. Then if you use covariance matrix, provide only the mean. If you use correlation matrix, you add standard deviation. Okay? So in our input now, is about covariance matrix. So let's go to the AMOS. So ang gagawin natin dito ay step 1 talaga. So punta tayo sa empty na AMOS. First step, every time we conduct an analysis, we save. Kahit empty pa yan siya, save na natin. So halimbawa, ilalagay natin itong file name ay PUP CFA project 1. Okay? So empty. So may file name ka na sa AMOS pero empty pa siya. Then, of course, we need to link our data and AMOS. Kasi ang data was stored in SPSS And we are using AMOS. Kaya ililink natin yan. So we can click File, then Data Files. So our file name, of course, we look at the file name. I put it in the POP folder. So male patients. Okay. So we have 500 respondents. It is reflected here, 500 respondents. Then we can click OK. So if you look at this icon, list of variables in the data set, okay, so we can see the active the list of the active data set. We have the P1, PS1, PS2, PS3, the waiting time, the nursing service 1, 2, 3. O, di ba? Then after this, i-drawing na natin yung ating the three latent variables. For the latent variable, of course, we have the oval. Then after the oval, we need to draw the boxes. So ang boxes, click lang natin yung latent variable. This icon, click that. Click that, then go to the oval. Then in the oval, i-click mo 3 times. Okay. So 3 times, ibig sabihin, 3 times we have 3 boxes. So 3 boxes, remember that this oval, for example, shall be for the physician service. So we right-click, point the cursor on the oval, then right-click, then click Object Properties, then type variable name. So under variable name, there should be no space. So ang makikita lang natin dyan ay, for example, physician service, PS. So ang PS, what is the meaning of PS? Pwede mo lagyan ito, physician service. Physician service. So yung physician service, pwede siyang mayroong space dahil variable label yan siya. Yung variable name mo, walang, ano lang yan siya, parang acronym lang. Para magkasya doon, so you can change the font size. So assuming that we will use 16. Kung hindi ka kontento sa 16, you can change it to 14. Okay, yan. So 14. So take note of the latent variable now. Our latent variable now consists of 3 items. So each box represents the item. So anong item ang ilalagay natin dyan? So of course, we go back to our list of items. Ang ilalagay natin dyan ay PS1, PS2, PS3. So you can go to the box, point your cursor, then right-click, then click Object Properties. So we type PS1, PS2, then we have PS3. So PS3 is for explains test and treatment. So PS2 stands for concern for comfort. PS1, we have the takes problem seriously. Yan. So these are our these are the items under physician service. Now, if you notice, one of the items, specifically PS1, has a regression weight of 1. Okay? Automatic yan, ang software ang nag-provide. But you can transfer it if you want. So meaning to say, you are sure that PS1 is an indicator of physician service. So you can transfer it kung gusto mo. You can transfer it to PS3. Basta isa, 1 out of the number of items, kung whatever is the number of items, at least isa dyan ay mayroong 1 na hindi at least, isa talaga. One of the items should have a regression weight of 1. That is a requirement in every latent variable. Kasi kung mawawala yung 1 na yan, yan yung question ni Sir Honesto Camino yesterday na hindi mag-proceed. Nung nag-trim siya, nung nagtanggal siya ng mga items, hindi nag-proceed yung computation because of that problem. Because of that nakulang, na nawala yung 1. Kasi kung tinanggal mo yung 1, tinanggal mo yung path na yan, tatanggalin mo, mawawala na yung 1. So dapat careful ka. And then aside from that, the error term should also have coefficient of 1. So software default, mayroong 1. Software default, yung first indicator loading mo has a regression weight of 1. So at this time, we can proceed to the nursing service. So the nursing service consists of 3 items. So mag-drawing tayo ulit ng panibagong oval. Okay, so like that. Then tatlong yan. So we call this oval as, tanggalin natin yung yan. Point your cursor, then click, right click, then object properties. So we call this as nursing service. So kung ayaw mo ng NS, kasi makalimutan ano ba yung NS. So you can type here nursing service. So you are allowed to put space for the variable label. So para consistent, you can utilize 16 as your font size. 14 pala kanina. So we have 14. Then close. So the nursing service, nasa list natin, the nursing service has 3 items in S1, NS2, and S3. So kaya pwede tayong maglagay dito ng NS1, NS2, then we have NS3 for the third box. NS3. That's it. Then the last one consists of 2 items only. So another oval. So another oval here consists of only 2 items. 1, 2, 3. Sorry. Undo na lang natin. Mayroong undo. Yan. So consists of 2 items, and the items are for the waiting time. So waiting time, WT1, WT2. So take note that the PS1, PS2, PS3 dapat ay nandoon sa SPSS mo. Di ba? Ito yung nanggaling sa SPSS, di ba? So PS1, PS2, PS3, these are the variable names in the data set. Kaya dapat consistent yung AMOS mo at saka yung doon sa data mo. Then yung WT1, this is for the waiting time. Okay? So this oval here stands for this oval represents the waiting time, WT. So for the waiting time, we can put a label waiting time. Okay, so pwede tayo maglagay ng 14. So it's up to you. Okay, so we have now the 3 variables. Actually, pwede natin yan paikutin. So you can use this, rotate the indicators of a latent variable. Click mo lang yan. Then go to the latent variable. Click mo twice. Okay? So, ganyan lang siya. Then, you can correlate the three variables. So, it's this lines, two-headed arrows represent correlations. Okay? So, ang kulang na lang natin ay yung label ng error in measurement. Measurement error yung ano na yan, o yung circles na yan. So, we can manually input the label for that, E1, E2, E3, E4. Pero the AMOS has the capability to put error terms. Pwede kang mag-click na click plugins, then click name unobserved variables. Diba? O automatic siya naglagay ng E1, E2, E3, E4, E5, E6, E7, E8. Unique ang label. Hindi pwedeng mayroon kang redundant. Then after that, the last one, we have the title. Yung title natin, i-click mo lang, then click somewhere in the drawing canvas. Then you can type here the value of chi-square. Chi-square equals \C min, meaning to say minimum chi-square. You can type also the degrees of freedom equals \df. Then you can type also the P because you want the value of P. So P equals \P. Then you can type the root mean square error approximation. So ang formula is root mean square error approximation. Next is the GFI, for example. GFI. We have GFI. Hindi naman siya case sensitive. So pwede kang mag-caps lock, pwede kang mag-small letters. CFI. \CFI. So hanggang dyan lang, halimbawa lang. Then you can align it at the left. Then click OK. So the left alignment can help us kasi it is helpful so that you can move kahit saan kung naka-left alignment. So you can put everywhere. Then after this, of course, save mo. Save. Although nag-save as ka na kanina, so you need to save again. Then after this, you can request the output. For example, kailangan mo ng standardized. So click mo yung view. Then analysis properties. So you can request for the output. So in the output button, output. So there is standardized estimates here. Then you can close this. Close this. So after this, na-request mo na, so you can now ask AMOS to calculate. So calculate estimates. Then, so the data file for group number 1 is in the wrong format. So a variable name PS3 in the first record, the file fails to match the variable. Okay, hindi na save yata yung ating ano. Wait. Yung ating SPSS file. Kasi ang alam ng software yung C5 pa rin. No? Male patients. Yes. Then for our file, then data files. So dapat ay nasa PUP. Okay. Then ang ating data, save. So group 1, calculate estimates. This gumana. Anyway, I can open another, kasi ang na-memorize niya ay C5 yan. A variable named PS3 in the first record of the file fails to match the variable name C5. Okay, so wala siyang, hindi na change yung ating so if we use this calculate, by the way, we need to check the data. This is the data. So we need to, okay, so file name. I will use the file from different male patients. Okay. Okay, so it was successfully computed. So I think there is technical problem in our newly created file. So for this, SPS stands for satisfaction with physician service. Then we have satisfaction with nursing service. Then SWT, satisfaction with waiting time. So hindi siya pumayag kanina na baguhin yung C3, C4, C5. Check na lang natin this afternoon. So in this particular data, or in this particular diagram, we can check the coefficients. So since the computation is successful, AMOS provides output such as text output. So we can click the view, then click text output. So there are plenty of outputs. For example, the outputs are organized by tab or by folder. For example, we have analysis summary. So the date of the analysis, the notes, for example, the 500 sample size, the variable summary. So the variable summary, we have the observed. Yung observed variable natin ay yung items. Then yung unobserved natin, yung error term, yung SPS. SPS stands for the satisfaction with physician service. Yung oval, unobserved yun. So next is the parameter summary. So we have the weights, the covariances, the means. So hindi naman tayo nag-compute ng mean, walang intercept, wala. Ang mayroon lang doon ay yung weights. Then we have the notes. So the number of distinct sample moments, degrees of freedom, the minimum chi-square. We have the chi-square 47.027, degrees of freedom, probability level. Ang probability level p-value dapat greater than 0.05. But we can use the other fit indices later. So about the estimates, so the estimates has two versions. The unstandardized, we call it regression weights. So we have this, ito yung halimbawa SPS, yung SPS na yan, ang ibig sabihin nun, yun yung kung ano yung naka-assign na 1, di ba mayroong 1, one of the indicators should have a regression weight of 1. So yun yung dito sa output na 1. Okay? CIS5 is assigned as 1. The regression weight for B6 is assigned as 1. Then indicator C1 assign ang 1 as regression weight. Then the rest are computed by the software. So for example, C4, so if we view again the diagram, so put it here. Okay, so para makita ninyo. Yeah. Diba? C5. So C5 in the output, C5 coefficient is 1. Then B6 coefficient is also 1. Then C1, the coefficient, regression coefficient is also 1. Now if we show the coefficients for the unstandardized, so lilitaw dito yung 1.024 as coefficient for C4. So this is C4, then 1.02. Then this is C3. C3, the coefficient is 0.95. So round off, naging 0.96. Then for the B1, B2, B3, B6. So B2 is 1.09. Kung i-round off mo yan, 1.09. Then B3 is 1.15. So this one is B3. Then B2, B6 rather. B6, the coefficient is 1. Now, if we shift to standardized, these are the standardized in the text output. Then if we shift this AMOS output to standardized, yan, 0.92 for C3, then 0.95 for C4, then 0.90 for C5. Yan. Then, for example, B6 is 0.90 in the diagram. Then, say, for example, C1 is 0.85 in the diagram. Okay. So here, the correlations between SPS stands for satisfaction with physician service, satisfaction with nursing service, meaning to say the correlation between SPS and SNS, the correlation is 0.77. So it is indicated in the diagram, but we have also output in the text, 0.77. We have 0.77 also. SPS versus SWT is 0.77. So we have this 0.768. Round off mo, 0.77. Correlation between SNS versus SWT is 0.85. Then 0.85 in the diagram. So if we try to look at the result of the standardized, ito yung sinabi ni Hare na dapat no indicator loadings less than 0.5. indicator loading should be 0.5 or higher. So, ibig sabihin, pasado yan. Pasado lahat. So, indicator loading should be greater than 0.50. Okay. So, the next thing that we need to view is the output about composite reliability, the Henseler, the Fornell and Larker, like for example, the square root of the average variance extracted. Okay. To do that, we just click plugins, then master validity. So there is master validity. So the output is Amos provides automatically the CR. CR stands for the composite reliability. So in this example, the CR for SPS, physician service, is 0.948. Then CR for satisfaction with nursing service is 0.948. Then composite reliability for waiting time is 0.860. Then beside the composite reliability ay yung average variance extracted. The average variance extracted should be 0.5 or higher. Then, if you look at the last three, the matrix, the last three columns, yung nasa diagonal, yung 0.927, 0.927, 0.868, these are the square roots of the average variance extracted. The square root of 0.858 is 0.927. The square root of 0.754 is 0.868. Then all these values, 0.770, 0.768, 0.851, lahat yan ay correlations between SPS, SNS, and SWT. For example, 0.77, this is the correlation between SPS and SNS. So yan yung correlation. So since all the correlation coefficients are less than the square roots of the average variance extracted, according to Fornell and Larker, 1981, these results indicate that the variables such as SPS, SNS, and SWT have discriminant validity. According to Hare, the average variance extracted are all greater than 0.50, indicating that there is convergent validity. Okay? So nakalagay dito validity concerns, no validity concerns here, meaning to say both content validity and convergent validity and discriminant validity are okay for this questionnaire. Okay, so that is about confirmatory factor analysis. Now I have a additional note for the master validity. So the master validity for version 23, I'm using version 23. We need to I need to emphasize that the master validity for version 23 does not provide the output for HTMT. So sa version 23, ang i-provide lang niya ay yung kay Fornell and Larker, yung ganitong matrix. Pero 26 and 27, versions 26 and 27, mayroong additional matrix dito sa baba for the HTMT. Okay. So I think I am done with my discussion about confirmatory factor analysis. So this afternoon, before I proceed to the, before I start the discussion about structural equation modeling, i-fix ko muna yung kaninang hindi nag-run na ating drawing. Tayo mismo ang nag-drawing kanina. Pinakita ko sa inyo, hindi nag-run. So kailangan yung data i-fixed. So I think I am done with the confirmatory factor analysis. So I give now the floor to Ma'am Hazel for the possible questions from the participants.
Okay, thank you very much po. May we all turn on our videos? Ayan, thank you po. Do we have any question regarding the lecture of Professor Johnny Amora for this morning? Ma'am Ria, parang may question si Ma'am Ria.
Wala, nagda-digest.
Nagda-digest daw, sir.
Yeah, actually, may gusto sana akong gawin, pero palagay ko hindi siya kasama dito. So, siguro later part na. Kasi I am trying, sir, to create a table for accuracy result.
Accuracy.
Yes, sir. Kasi wala pang, bawa nagagawa kami research, tapos may result kami accuracy. So I was trying to create a table na magiging, parang magiging ano siya, kasi di ba sabi niyo, sir, pwede siyang ma-publish, yung mga ganyan. So
Yes.
what I was trying to do right now, na palagay ko hindi valid dito sa area ng subject na to, is to create a standard for accuracy testing output for its interpretation.
So accuracy scale po yun? Or
yes, parang ganun po, sir. Pero in the field of sentiment analysis. So,
yeah.
Sabi ko, siguro, parang ganito rin yung dapat kong gawin. Gagawa ko ng mga ganitong mga diagrams.
So that might be a possible publication in the future.
Yes, sir. And that
within the year,
once,
actually.
Yes, sir. And once published, kasi yan yung po yung problema namin sa field namin ng NLP, wala kaming makitang standard accuracy rating scale. So, unlike others, kasi sa field ng technology, sa machine learning po ito, AI po ito. So, tinitignan ko po yung area na pwede akong gumawa ng isang standard para pag yung mga students ko may ganun, pag hinanap, sabihin, ito. Tapos pag sinabing ito, sasabihin kasi ng mga faculty, bakit? Valid ba yan? Valid ba yung table na yan? So, at least may validity testing. Tama po ba? Hindi ko alam kung dapat siya dito pumasok.
Opo. At least na-open yung mind mo na pwede palang mag-research ka. Mag-start ka sa instrument validation.
Yes, sir.
Yeah. Tama
kasi
po yun.
Kala ko, I am not in the position to do that.
Of course, may position tayo.
Hindi po ako statistician, so hindi ko po alam kung paano. So, pwede po pala, pwede gawin yung ganito.
Yes po.
Medyo iba lang po siguro yung style na gagawin ko for this. Tapos po, sir, yung ginagawa nyo pong, walang tanong no? Yung pong ginagawa nyo, sir, na 8, ano ba yun? Yung sa
8 dimensions, yung digital preference.
Sir. Yes, sir. Babalik na naman po ako dun sa question ko yesterday na pag po ba nagawa nyo na yan at gusto kong gamitin yung inyong questionnaire dun sa PUP naman, just to test yung kanilang tawag dito, kung okay sila sa online, di ba? Ganun po yan yung testing digital. Pwede po ba or kailangan na naman gumawa ako ng
kapag na-publish na namin yon, ibig sabihin public consumption na yon. So you can adapt the questionnaire.
So, if I'm going to adapt the questionnaire, I don't need to use a confirmatory. I don't need to do a confirmatory test.
Dahil Filipino naman ang author, the instrument was developed by in the Philippine setting. So, pwede ka nang hindi ka na mag-conduct ng factor analysis. Pwede mo na lang i-report na lang yung reliability, provided na yung mga items ay relevant to PUP. So, Maliban na lang kung hindi siya relevant, magdagdag ka ng bagong mga variables, bagong items. Pero that is another research. Kasi yung
Test na
existing,
naman.
oo, kasi yung existing, yung halimbawa, yung amin, ma-publish na yon. So, yun yung existing.
Yes po.
Ngayon, nakakita ka ng weakness dahil hindi ma-apply sa PUP. So, mag-create ka ngayon ng additional variable. So, that would be your contribution again. So, another publication po yan. Yeah. Kung magdagdag ka ng variable, that's another publication.
But that would be a result after using your table, your instrument.
Questionnaire. Kahit hindi mo pagagamitin, tapos nakita mo yung kulang, 'di ba? Iba naman ang culture ng PUP, iba din ang Lasal. So kung nakita mo na mayroong kulang, kung may kulang, pwede kang mag-extend. So extend mo yung theory nila ni theory ni Amora, extend mo. So that would be another publication in your part.
And malalaman ko lang po na kulang, depende kung yung data ko hindi sumasagot sa gusto kong sagutin.
Yes po.
Okay,
Kung
so
halimbawa, 'di ba 8 'yon. Tapos gusto mo magdagdag ng bagong variable na fitted sa PUP, pwede. Magdagdag ka. So that would be another research.
okay. So,
Extension of the existing theory na ang digital preference has 8 dimensions. So later on, sabihin mo, dapat 9 ito dahil 9 ang sa amin sa PUP. Mayroon kaming component na ganito na hindi nasama doon sa existing. So you can propose. Gagawin mong 10. So no problem. Basta fit doon sa ano nyo, sa PUP for example.
okay. Siguro po sir, meron akong ipapa-advise sa inyo na personal kasi it's about my research in technology acceptance.
Technology acceptance model
Na meron na pong ginagamit ang international na iba't ibang bansa na po ang gumamit. So, ang iniisip ko po kung gagawa pa rin ako ng confirmatory doon, although kasi ang dami ng taga-ibang bansa na nagamit as is.
Okay.
So, naging international model na po siya talaga.
Actually, mayroon ka, we have research just released last July 17, naka-publish na sa Scopus Journal. We use the extended technology acceptance model. So, available yan sa aking kung gusto niyo.
Sino pong basis, sir?
Pwede nyo tingnan sa aking Facebook.
Ay, sige po, sir.
Doon. Online naman yung journal.
Sir, pag yung ginamit ko, setting na ng Philippines.
So, actually, Extended Technology Acceptance Model. So, ETAM. Yeah. So, same pala tayo ng research area.
Po, sir. Tapos po yun, doon na lang ako magtatanong.
Yeah, yan. Doon sa Facebook account ko,
Yes, sir. Bale, yung po yung technology acceptance of PUP po ang gusto kong pasukin.
Pwede po yan.
Sa field ng human resource management.
Yes po. So, yung amin is an additional contribution to the literature of actually LMS, Learning Management System, and we utilized the model called Extended Technology Acceptance Model.
Okay. Sa akin naman po is the Human Resource Information System.
Okay.
Salamat po, sir.
Related lang yun, ma'am, kasi ang gagamitin ninyo ay Technology Acceptance Model. Tama?
Yes po. Yes
yun.
po.
Related lang.
Thank you po.
Opo.
Ayan. Thank you, sir. Thank you, Ma'am Ria. Mukhang marami ng research si Ma'am Ria na maperform after this training. Okay daw po, sir. Dalawa daw. Wow. Okay, may questions pa po tayo. Sir Ernie, may question po kayo, sir?
Ma'am Hazel.
Wala naman.
Ma'am
Yes po.
Hazel.
Ay, Sir Camino.
Sir, I go back to the basic, doon sa questionnaire. Ano ba yung reason kung bakit ang ating, let's say, grouping o variable ng category sa variable, let's say age, interval of 5, interval of 10, ang daming researches sa ganun eh. Hindi ba mas maganda kung yung categories ng ages ay back up ng theory ng human development or life stage?
Pakiulit yung ano sir, yung part ng ano, hindi ko na-capture. Sorry.
Sir, yung pong ba, basic po ito, yung question. Halimbawa, demographic variables we're going to use for the description of the respondents and in explaining phenomena in the study. Ang daming researchers gumagamit, as in the case of age, naka-interval lang ng 5. Pero I search for literature or even theories na nagsasabing ages should be categorized by 5, by 10. Wala po eh. We found out ang mas meron ay yung theory ng human development or life stages na hindi uniform yung interval ng ages.
So, ano ang sinasabi doon, yung actual age?
Oh, hindi siya yung interval of 5, hindi siya yung interval of 10. Iba-iba po ng interval. Ang dinidescribe na phenomenon ay yung anong nangyayari sa ganitong group of ages.
Okay.
It's only in the case of age. Other variables also have siguro ibang theories na magde-describe ng categories within the variables.
So yung age mo sir, example mo lang yun?
Opo.
So wala namang ano eh, o kung descriptive statistics lang naman yun, yung grouping. So wala namang general rule about the grouping kasi it depends on your respondents. Sabi mo kanina 5 categories. 5 age categories, parang something
interval
like
of 5, interval of 10, like that.
So wala namang general rule when it comes to the interval. So ano lang yan. Actually, ang advice dyan is you can use the actual age. Then after the gathering of the actual age, at saka mo pa i-categorize.
Okay, sir.
Minsan kasi sir, yung questionnaire natin, nakalagay na doon yung age bracket. Pipili na lang yung respondents. Check na lang niya kung saan siya na-belong. Depende po yon sa goal natin. For example, mayroon tayong study about senior citizens. So hindi papasok yung ibang age group dyan. So ma-reduce yung ating age group. Pero kung ang respondents natin ay all ages, so different intervals na naman yun. So walang fixed na number of intervals.
Sir, ang point ko sir ay even yung demographic variables lang, di ba dapat ay theory-based din yung ating pagka-categorize nung...
Correct, sir. Correct ka dyan, sir. Tama ka. Bullseye. Dapat theory-based. Yeah.
Thank you, sir.
Opo. Welcome.
Ayan. At least, sir, na-clarify din sa amin regarding yung question ni Sir Oni Camino. Kasi, totoo naman, mahirap din maghanap ng basis regarding dun sa interval nung sa age. So, sometimes, talagang based na lang sa researchers, no, sir? Kung
mas maganda, based on theory.
Apo. Ayan. Okay. So, may questions pa po tayo?
Hazel.
Yes po.
Sir, this is not related po sa sa yung presentation. Di ba, sir, nire-record po namin yung ating session? Can we use this, sir, para then to share this to our faculty members then sa college? Okay lang po ba?
Okay lang po. Yung recorded.
Yes,
okay
sir.
Lang po. Yes po.
Thank you, sir.
Ayan, meron pa po tayong questions. Sir Ernie? Wala.
Ma'am, magtatanong po.
Yes po.
Ayan,
Sir.
okay.
Sir, magkano po ang membership po sa Parsu?
Sa Pars. Membership, sir, is 600 per year.
Per year.
Mm. 600 per year.
600 per year. Kasi I think most of us po, sir, ay magpapa-member po. Magpapa-member po
Okay.
sa Pars.
Mm.
Ayan. Okay, so kung wala na po, yes po.
May isa pa. Sorry.
Yes, sir. Sir Oni. And Ma'am Ria after. Okay po.
Sir, yung nabanggit niyo po kaninang factor analysis, as I was jotting down notes, nabuo sa idea ko na can we consider factor analysis as a mixed method of quality and quantity? Kasi yung pong parang idea ko dito, nung nag-grouping na yung indicators, we have the task of labeling that set of indicators and explaining what that group of indicators mean, which is qualitative in nature. Am I right, sir?
Correct, sir.
Iterative, quality.
Yes, sir. Pwede.
So we can claim if we use the factor analysis, we are doing mixed method.
Pwede naman mixed method, sir, kasi yung iba, they conducted a focus group discussion, for example, in order to draw the dimensions. Diba? So focus group discussion, you can generate the dimensions through a focus group discussion. Then after the generation of the factors or dimensions, you can conduct factor analysis. So mixed method. Kasi focus group discussion, ano yan siya? Ano yan siya? Quali. Diba? Quali. You derive the factors or dimensions using quali approach. Then later on, nagkanda ka ng confirmatory factor analysis to confirm the theory that you have generated using quali. So quali then plus quanti. So mixed method na siya.
So even, sir, yung pagle-label ng factors, quali pa rin siya. Yung pagpapaliwanag ng factors.
Yung pagpaliwanag ng factor, ano lang yun, sir? Halimbawa, nag-confirmatory, exploratory tayo. We have 50 items, for example. Nag-confirmatory tayo, then ang result natin ay, say, for example, 5 factors na lang. So, of the 5 factors, mayroon naman siyang mga items that belong to every factor. Yung ibibigay mong label sa bawat factor should be based on the theme. Theme doon sa mga items. So actually yun yung ano sa labeling na yun sa interpretation na yun ng factors. Pwede ka rin sabihin mo na mixed method, pero sa buong factor analysis part talaga yun yung pagbigay ng pangalan ng bawat factor. Kasi pwede ka naman, sir, mag-ano doon mag-recall ka ng mga literature, di ba? Pag nagbigay ka ng label for every factor, you can utilize your review of literature na yung factor 1 can be called like this. So, quali pa rin.
Okay.
Quali part.
Thank you, sir. Thank you. Thank you po.
Welcome po.
Ma'am Ria?
Yes. Kasi nagtanong na tungkol dun sa mga parso, tawag dito, mga activities. Opo. Sa akin naman po, ang tinatanong po, kasi po sa field ng information technology, computer science, we find it very hard to analyze yung data, like yung mga tanong ni Sir kahapon na what would be the numbers, the sample size and everything, if we are trying to consider data analysis for, let's say, application software that we have created, yung mga ganon. So meron po ba ang Parso na mga trainings na focused lang siya for statistical data analysis for IT research, computer science research, to help our faculty members in Chapter 3 actually. Actually, sa Chapter 1, yung palang conceptual framework going to the methodology of research po. para hindi po nagkakagulo-gulo. Kagaya ni reliability test, pinipilit nila ipasok si cronbach, for example, for reliability, for software reliability. So, ang pasok naman po natin, cronbach is being used for instrument analysis for the reliability of the instrument. So, siguro po, para medyo ang aking pong mga kasamahan sa field ng CS and IT dito po sa PUP ay mabigyan po ng seminar just focusing on what to be used if, for example, we have this type of research, or can it be used ba or cannot be used? Parang ganun po. Kasi minsan, questionable sa amin ng reliability testing, accuracy testing, and so on and so forth, na baka po pwedeng matulungan kami ng PARSO dito.
Okay. So actually, mayroong training ang PARSO by August 29. So, i-share ko sa screen yung title of the webinar. Okay, so ito po yun. So, I think makikita nyo sa screen. Sorry. Yan. This is August 29. The first session is 1 to 3:30. Easy way of choosing the right statistical test. Then second is sample size determination using software. So far for August, yan pa lang po.
Okay. So basically sa general to, ano?
Opo, pwede naman mag request yung kung marami naman kayo doon sa department po ninyo.
Opo.
Pwede naman tayo mag para lang sa inyo.
Para focus po dun sa field ng computer science
Opo,
and IT.
computer science, opo.
Ilan po yung minimum attendees po, sir, para request?
I-determine muna natin yung ano, ma'am, yung design muna natin kung anong topic ang i-offer natin para we can develop the training materials.
Okay, sir.
Opo.
Sir, makikipag-communicate na lang po ako tungkol dito.
Opo.
Thank you po, sir.
Welcome po.
Yeah, okay. May questions po tayo or concern?
Sir, yung salitang robot photo ba, accepted na siyang gamitin in lieu ng demographic profile?
Okay. Robot photo is UST kaya ata, sir, di ba?
Sa UST ko, sir, nakita.
Yes, tama. Kasi yun ang ginagamit nilang terminology.
Oo nga,
Opo.
sir.
Oo. Kaya ano yan?
Sa kanila lang o pwede naman natin gamitin?
Pwede naman natin gamitin, sir. Pero ang alam ko, ang una kong narinig, UST ang gumagamit sa terminology na yan.
Oh, sir. Sa UST ko rin po nakita eh.
So, di ba sa UST, ano din, simulacrum. Di ba? So, mayroon silang mga terminology instead na diagram or the framework, conceptual framework, simulacrum ang tawag nila. Tapos robot photo naman sa profile, di ba, sir? Demographic profile.
Yun lang naman.
Opo. Opo.
Ayan. Okay. May questions pa po tayo or concerns? Alright, sir. Mukhang wala na po. So, we'll first have our lunch break.
Yeah. Lunch break muna tayo.
Sir, anong oras po tayo magre-resume?
Sabi ni Sir Orotia, ni Dr. Orotia is 1 o'clock. So, nasa inyo po kung anong request ninyo. Masunurin ako.
I think okay lang naman, sir, para medyo maaga rin tayo.
Maaga din tayo matapos.
Na makatapos. So,
okay.
We'll just, please do not leave the meeting room. Same as yesterday na lang po yung gawin natin. Yes. And hopefully, Sir Dr. Urrutia and the other chief will be able to meet us this afternoon kasi alam ko po medyo may ginagawa po sila sa office. Okay. But then, Opo, no. So, we'll see you again at 1 o'clock this afternoon. Meron pong prepare si Sir Nartea na activity, opo, before our afternoon session, sir. Ano yan, sir?
Oo nga. Ano prepare mo?
May pa-games tayo, may pa-premyo.
May games po tayo mamaya. May prizes din. Opo, so please be in the meeting room or let's all be back before 1 o'clock. Siguro mga 5 minutes before 1 o'clock, Sir Mekmak,
Okay.
no?
Wala akong alis.
1:55.
Wag na lang pong
Ay,
mag-leave.
12:55 pala, sorry.
Wag na lang pong mag-leave. Parang yung yesterday na lang para mabilis tayong makabalik.
Play lang ako ng YouTube video.
Okay. Sir Daryl, thank you sa pag-record.
Thank you.
Okay po.
Before I proceed to the structural equation modeling, let us go back to our data set this morning. We changed already the variable names, PS1, PS2, PS3 na. Then this morning, we forgot to change the other side of the data set. In the data view, we forgot to change this. So we were not able to run successfully the AMOS because we forgot to change this part. So now that I changed, if we go back to our AMOS drawing, AMOS diagram, then calculate. So analyze, then calculate. So we have this diagram. So we successfully computed, or the computation is successful. So we have now the PS1, PS2, PS3. So earlier, or this morning, we used the C3, C4, C5. So now we changed it to PS1, stands for Physician Service. Then we have NS 1, 2, 3 for the nursing service. Then finally we have the lastly we have the waiting time, WT1 and 2. So yun lang, ang sensitive siya. Kailangan lang natin ayusin yung both sides of the SPSS. So for the variable name, so ito yung PS1, PS2, PS3, WT1, WT2. Then dapat dito din sa data view, babaguhin din natin this part. Ito yung mga variable names. Okay? So yun lang ang wala kanina, kaya hindi nag-run. And now I will proceed to the structural equation modeling, which is the topic for this afternoon. Okay, so for structural equation modeling, let us recall again that when we talk about structural equation modeling, it is part of the number 7. So tools for testing and modifying an existing theory. Okay, so it's number 7 because structural equation modeling is one of the tools for testing and modifying an existing theory. So in other words, we have already the theory, then our goal is to test. Then later on, after testing, if the result is acceptable, then tapos na ang project. But in case after testing the model is not acceptable, then you need to modify the model. So structural equation modeling is one of that. And the other one is, of course, the path analysis yesterday. So the path analysis is part of number 7. Path analysis and structural equation modeling differ only on the variables. under investigation. So for path analysis, the variables are all observed, while the structural equation modeling, the variables can be mixed of both observed and latent variables. Another tool for testing and modifying an existing theory is the CFA, the confirmatory factor analysis. So far for number 7, tatlo na tayo. Meron tayong path analysis, meron tayong confirmatory factor analysis, and now we will discuss the structural equation modeling. Okay, so for today, for this afternoon, so we will review the path analysis. So just very fast, then confirmatory factor analysis, then of course the covariance-based structural equation modeling, which is the primary topic for this afternoon. So all of these are in the number 7 category. So ECM is a tool for testing and modifying an existing theory. So for the path analysis yesterday, we discussed, we mentioned that path analysis was developed by Sewell-Wright in 1918. Then this geneticist Sewell-Wright wrote more research on in 1920s. Then during the time of Sewell-Wright, there was no concept about latent variables yet. So in other words, during his time, the variables are considered as observed variables. So one example again for path analysis is the regression. So we have the dependent, we have the satisfaction, and the independent variables are delivery speed, manufacturer image, and overall service. So we can we call this regression model as regression path model. A very simple example of path model. So we have the outcome variable. So we have also path from each of the predictor variable going to the outcome variable. So kaya path model pa rin siya. So another one, the complex one is this. There is no more the term dependent variable is changed to endogenous variable. Kasi yung dependent variable hindi na siya applicable dahil nga sa it is a path model. Yung variables, may possibility na one variable can serve two functions. For example, self-efficacy. Self-efficacy is a dependent variable with respect to parenting style. Then in the same model, self-efficacy is an independent variable with respect to self-regulated learning behavior. So dual ang function. So the word dependent variable, or the terms dependent variable, is replaced by the words endogenous variables. So the independent variable now, so the permissive parenting style, authoritative and authoritarian, exogenous variables yan because they are not dependent on other variables in the model. Okay, so yesterday we discussed about this. We started with a research model. Our research model is basically a representative of our framework. Sa ano kasi, sa mga publications, especially if we publish in the Scopus journals, So hindi naman talaga kailangan i-specify mo kung conceptual framework or a theoretical framework. Yung ilalagay lang naman natin doon ay research model. The research model can be represented by a path model, and this path model or the research model is a representative of our theory, the theory that we want to investigate. So the proposed theory represented by the research model is confirmed if the sample and data, or the sample and the model, the path model are consistent, statistically consistent. So yesterday, so that we will know that the sample data and path model are consistent, statistically consistent, the value of P should be greater than 0.05. Then in case na hindi talaga ma-achieve yung P value, we can utilize the other fit indices. For example, the RMECA, the root mean square error approximation, the GFI, GFI stands for goodness of fit, the CFI, the NFI, so maraming mga fit indices. Then if the if the sample and model are not well fitted, meaning to say the consistency is not acceptable, the researcher should look for a well fitted modified model, meaning to say we modify our model. So just like this, so this is our conceptual diagram. The conceptual diagram, basically this is the conceptual framework. We can test that after the gathering of data. We can test this diagram, and after testing, we can be able to determine the value of P. So the value of P value can serve as our criterion for judging whether the model is acceptable or not. If the P value is less or greater than 0.05, so we can say that the model is is acceptable. So in this example, the value of P is 0.000. So it is not greater than 0.05. So it means that your framework, your proposed framework, your proposed model does not work. Does not work, meaning to say your model, your framework is inconsistent with the data. So the data that you have gathered is or are inconsistent with the proposed model. So that is why you need to modify that model. The modified model is below. The P value is greater than 0.05 in this example. Greater than 0.05. So it's basically 0.655. So there is a modification of your framework. The framework does not include the relationship between attitude, subjective norm, and perceived behavior control. So now your new model, your alternative model now has a suggestion that these three variables should be correlated. If you correlate these three variables, your P value will improve. So it becomes acceptable. Okay? So in real research, just in case na hindi siya acceptable kahit na connect mo na yung mga variables, yung mga boxes na connect na lahat pero hindi pa rin nag-improve ang value ng P, you can utilize the other fit indices. Okay? So another example, this is the simple example, simple model. So assuming that this is our framework, This is the framework of the researcher. Then we gather the data. Then after gathering the data, we come up with this result. So the p-value is 0.000. So it is not acceptable. But when we tried to improve, when we tried to improve the model, there are possible paths that needs to be connected. For example, the quality of elementary school has effect on teacher recommendation, parents preference, and school test score. Yung quality of elementary school ay mayroong link, mayroong path. May pathways from quality of elementary school going to each of the three variables at the right side. So yan yung example na pwede mong i-modify so that the p-value becomes acceptable. And of course, you need to check kung relevant ba or may theoretical basis ba kung i-connect mo. So may sense ba kung i-connect mo yung mga variables with arrows? Kasi ang meaning ng arrow, one variable influence the other. One variable influences the other. Or one variable causes the other. Yun kasi ang ibig sabihin nung arrow. So there are many terminologies. We can use one variable affects the other, or one variable influences the other, one variable causes the other. Okay, so in other words, simply lang, so you can propose a framework, then after the proposal, you gather your data, then subject your data to statistical investigation based on the framework. So if the statistical fit is not acceptable, modify your model. So kung makaproduce ka ng modified model, much better, because the modified model would be your proposed theory. So yung result mo, contribution mo na yan sa field mo. Okay, so for the goodness of fit, we can utilize the work of Engel, Karen, Mosbrugger, and colleagues. So marami yan sila, 1, 2, 3, 4, 5, 6 authors. There are 6 authors in this paper in 2003. Okay. So for the confirmatory, this morning we tried to discuss the concept and application of confirmatory factor analysis. So when we use confirmatory factor analysis, there should be an existing theory about the factor structure of the scale to be confirmed. So for example, if in our example earlier, patient satisfaction has 3 factors. Satisfaction with physician, satisfaction with nursing, and satisfaction with waiting time. Then the 3, the entire scale, which aims to measure patient satisfaction, consists of 3 subscales. So yun yung theory, and the 3 subscales are correlated. Okay, so another example, you have a theory states that teaching performance can be assessed using 4 correlated factors: planning and preparation, classroom environment, instruction, and professional responsibility. Okay, then we can draw the diagram. So if the theory states that the factors are correlated, then we connect the ovals with double-headed arrows. The double-headed arrows represent the correlation between ovals, and the ovals, or each oval, represents the factor. So in our example, planning and preparation, classroom environment, instruction, and professional responsibility are the factors. Then the items, of course, in the boxes. So see to it that the items dapat mayroong literature na yung mga item are really indicators of planning and preparation. Okay, so the objective of CFA is to test whether the data fit with the CFA model. So basic steps, as discussed earlier, these are the steps. Discuss the theory to be confirmed, prepare the survey questionnaire, then gather the data, then draw the CFA model, then present the following. Diagram with estimates, goodness of fit and fit indices, convergent validity statistics, discriminant validity statistics, as well as the reliability. So earlier we had this example: physician service, nursing service, and waiting time. So physician service consists of 3 items. Then the nursing service consists of 3 items also. Then the 2 indicators, or the waiting time, consists of 2 indicators. Okay. Then, as discussed this morning, the 3 subscales are correlated. So the correlated subscales and the respective indicators are depicted in the diagram. So exactly yan yung ating diagram. Ano lang siya, gumawa tayo kanina ng oval, then the oval represents the subscale. So each oval represents the subscale. Sometimes we call it latent variable, sometimes we call it factors, sometimes we call it construct. So there are many terminologies when we talk about confirmatory factor analysis. Then, of course, the next step is to present the goodness of fit and fit indices, including the values. Then do not forget to put a remark, because the last column can tell us that your model is acceptable or not. And we want that your model is acceptable, of course. So if it is not acceptable, so obviously we need to review the items. So at the item level, you need to review the indicator loadings, whether the indicator loadings are 0.5 or higher, whether the indicator loadings are statistically significant. So yun lang naman natin tingnan natin. Then after that, we also review the average variance extracted, whether the AVE is 0.5 or higher. Then if the indicator loadings as well as the AVE are okay, then the convergent validity also is okay. So after that, we need to check the convergent validity. So as I mentioned, you look at the indicator loadings, the average variance extracted. So na-discuss naman natin ito kanina, so kaya mabilis lang ako. So here we have the indicator loadings should be significant. So ang p-value niya dapat less than 0.05. Then ang actual value ng indicator loading should be 0.5 or higher. So mayroon naman tayong reference. So here and colleagues. Then for the average variance extracted, we see to it that the average variance extracted is 0.50 or higher. So just in case hindi ma-meet yung average variance extracted, halimbawa ng instead na 0.5 or higher, nagkataon na below 0.5, what shall you do? So of course, you review your indicator loadings. So your indicator loadings, if you remove indicator loadings with indicator loadings na below 0.50, so hindi yun nakakatulong sa average variance extracted. Tanggalin mo yung items na yun, then rerun the CFA. So pag na-rerun mo na yung CFA, ma-recompute mo rin yung average variance extracted. So mag-increase yun. Meaning to say, if you remove indicator loadings that are below 0.50, mag-increase yung average variance extracted. So these are the indicator loadings of our items earlier this morning. Indicator loadings are 0.5 or higher. The average variance extracted are also 0.5 or higher. So meaning to say, in terms of indicator loadings, in terms of average variance extracted, yung data mo okay. So meaning to say, your variables have convergent validity. Then we attempted to discuss the discriminant validity. When it comes to discriminant validity, it is something about testing whether the items or the indicators or the respondents are not confused with the items in the questionnaire. So the item should be clear by the respondents. Dapat naintindihan nila. Otherwise, kung na-confuse sila, yung pag-measure mo ay hindi tama. So invalid. Kapag na-confuse sila sa items mo, ibig sabihin, mahina yung discriminant validity ng variable mo. Yung, for example, ang ibig sabihin ng variable, again, yung satisfaction, yung satisfaction with waiting time, satisfaction with nursing service, yun yung mga variable. Then mayroong mga indicators doon, kung nalito sila, hindi nila alam para saan ba yung item na yun. Yung statement na yun, para saan ba yun. So, is it for the nursing or for the physician? So kapag ganon, nalito sila, so there is something wrong with your questionnaire in terms of discriminant validity. So there are two types or two approaches on how to assess discriminant validity. The first one is the old one, recommended by Fornell and Larker, and the requirement is that the square root of the average variance extracted of the variables should be greater than the correlations among the variables. Okay. So another recommendation is given by Henseler, Ringel, and Sarsted. Recommendation about assessing discriminant validity. So sabi nila HTMT ang gagamitin based on their paper in 2015. So ang threshold 0.85, sabi nila dito, thresholds are 0.85 for strict and 0.900 for liberal discriminant validity. Okay, so for example, I have here a sample output about discriminant validity based on Fornell and Larker. So yung SP, SWT, and NS, yung nasa diagonal, yan yung square root of the square root of the average variance extracted. All numbers in the off diagonal are correlations. So to have discriminant validity, the numbers in the diagonal should be greater than the numbers in the off diagonal. So another one is the Fcmt. This is part of the output of AMOS. We have the requirement by Henseler and colleagues in 2015. If the HTMT is less than 0.85, so it means that it is a best discriminant validity. Then the liberal threshold is 0.90. Sabi ng paper na yan, kapag less than 90, ang tawag natin good validity or good discriminant validity. So based on this example, ang pinakamalaki dito ay 0.845, followed by 0.775, then 0.771. All the three are less than 0.85. So it means that the variables such as satisfaction with physician, waiting time, and nursing service have discriminant validity. So the discriminant validity level is best because all values, all HTMT values are less than 0.85. So yan. Then we will proceed to the correlations. So ang correlations natin as discussed this morning, 0.7 ang Cronbach alpha, or kung relaxed criterion, 0.7 ang composite reliability. Just in case na medyo mababa ang ating composite or Cronbach alpha, we can utilize the paper of Nanali and Bernstein in 1994 as our reference so that we can use 0.6 or higher. 0.6 value of Cronbach alpha is acceptable. So in our physician service, nursing service, and waiting time, ang ating composite reliability ay matataas. The lowest is 0.86 for the waiting time. Okay, so I will proceed now to the structural equation modeling. Mabilis lang yun dahil review lang naman yun. For the structural equation modeling, dito magdandahan ako. So SEM, if you combine the path model and CFA, the result of that is structural equation modeling. In other words, when we talk about structural equation modeling, mayroon na talagang kasama dyan yung path model at saka CFA. So this SEM, the development of this started in 1969 by Carl Jaresko, 1969. So if year 1969, so it means na 51 years old na ang structural equation modeling. Okay? Sabay sila sa confirmatory factor analysis. Kasi si Jaresko din ang nagpasimuno ng confirmatory factor analysis. Okay, so an example of structural equation model is this. If you look at product as a variable, okay, so product is a latent variable, value is another latent variable, service also is another latent variable. So it means that this model, we call it a structural equation model. The primary variables of the study are value, product, and service. In order that the researcher can measure value, the researcher needs items. under value. For example, there are 3 boxes for value. It means that the researcher has 3 indicators, available indicators to measure value. So, nilagyan niya nito ng val 1, val 2, val 3. Clerical error lang yung isa. Then for every item, there is corresponding error in measurement. Di ba yung value, if we recall our discussion this morning, yung value na yan, dahil palabas yung arrow, reflective, latent variable ang value. Meaning to say the items are correlated. Okay? For the product, so that the researcher can measure the product, kailangan niya ng mga items or indicators. Indicators for product. Product 1, product 2, product 3, 4, and 5. So ito yung nasa questionnaire. So for service, the researcher utilized the 4 indicators: SVC1, SVC2, 3, and 4. So in other words, if you count the number of indicators, we have the 4, then another 3, then another 5. So it means na 12 in all. There are 12 items in all in the questionnaire. Nabuo na niya yung kanyang project, kanyang research na value, product, and service. So, mayroong arrow from product to value, indicating that the researcher wants to investigate the effect of product on value. Okay? At the same time, the researcher wants to investigate the effect of service on value. Kasi nga ang primary variable niya ay value, product, and service. So, product and service have effect on value. Yan yung hypothesis niya. And because the researcher wants to predict value, gusto niyang i-predict ang value dahil may arrow from service, from product and service. So ang mga predictors niya ay product and service. So in predicting value, there should be a error in prediction. So ito yung var underscore error. Error in prediction yan. Then at the same time, in the same model, there is there is a double-headed arrow pointing to product and service. Yung may coefficient na 0.48. The 0.48 is correlation between product and service. Okay, so ang ibig sabihin lang dito, tatlo lang ang kanyang hypothesis. The first hypothesis is product affects value. Second hypothesis, service affects value. Third hypothesis niya, service and product are correlated. Okay. Sa mga publication, lalo na sa mga Scopus journals, palaging hindi null hypothesis. Mahilig lang tayo sa null hypothesis sa loob ng university. So, maraming universities sa Philippines na observe ko, puro null hypothesis. Pag sa mga publications, hindi naman null hypothesis. So, there is mismatch between the skills provided by the university and the research outputs required by journals. Kasi pagdating na sa journal, hindi naman null hypothesis ang kailangan doon. Yung mga yung mga legit na journals, mga mataas ang standard, hindi naman null hypothesis ang kailangan doon. Basta research hypothesis, yun na. Okay. Another example is this paper. The paper consists of 4 variables. So the variables in this paper are institutional support, then academic performance. We have another variable, student engagement. Then another one is the college experience. Of course, yung bawat oval dyan, there are corresponding indicators. So hindi na lang namin pinakita yung mga indicators dahil masagwa na tingnan kung maraming items. In fact, we are just interested of the interrelationships among the variables. So kung titingnan mo yung institutional support at saka academic performance, yung dalawa muna, ang tawag dyan ay dependent variable yung academic performance, independent variable yung institutional support. Tapos yung aming student engagement at saka college experience, tinawag namin yung mediators. Okay? So kaya yung first hypothesis namin is the link between this oval, institutional support, and academic performance. So that was our hypothesis. Institutional support is directly related to academic performance. Okay. The number two focuses on the 3 variables: triangle, institutional support, student engagement, and academic performance. So kapag triangle, in the triangle, the third one is the mediator. So of course, i-review mo ang literature, see to it that institutional support has effect on student engagement. So dapat may literature review ka dyan. Then there should also be another articles stating that student engagement affects academic performance. Then there is also an articles or set of articles indicating that institutional support has effect on academic performance. Yung tatlo na yan, maaring may mga link na yan, pero hiwa-hiwalay na articles. Ibig sabihin, maaring mayroong publications before, investigation about the effect of institutional support on student engagement. Then another article, effect of institutional support on academic performance. Then another article, effect of student engagement on academic performance. So kapag nabuo na yung triangle na yan, ang ibig sabihin, student engagement mediates the relationship between institutional support and academic performance. Okay, so pwede yun, allowed yun. Kahit nga 3 variables lang, pwede. Kaso yung amin, 2 ang mediators. So yung another triangle, institutional support and college experience going to academic performance, it's another triangle, kaya we have another hypothesis. College experience mediates the relationship between institutional support and academic performance. Then lastly, it's about sequential mediation. Dahil dalawa aming mediators, at saka yung mediators have causal relationship. Ibig sabihin mayroong arrow from mediator 1 going to mediator 2. So swak yan siya sa literature about mediation. Kasi sa literature about mediation, mayroong sequential mediation. Kaya yung fourth hypothesis namin is student engagement and college experience sequentially mediate the relationship between institutional support and academic performance. Ibig sabihin, if there is sequential mediation, ibig sabihin, yung institutional support affects student engagement, then student engagement affects college experience, then college experience affects academic performance. Kapag significant yung tatlo na yan, ibig sabihin mayroong sequential mediation. Okay? So, yun lang ang yung apat na yan. Apat na variables. This is a simple mediation equation or mediation model. So, sa kanyang model, yung right side, intention to quit. So, IQ, intention to quit in the organization. It is affected by transformational leadership and employee engagement. Kaya mayroong arrow. So, of course, ang ginawa niya, the author reviewed the literature for effects of transformational leadership on employee engagement and intention to quit. Then another review, employee engagement and intention to quit. So hiwa-hiwala yung mga articles na yun, di ba? So wala pang study about these three. Wala pang existing during the time of Dr. Lacap's when he formulated this paper in 2019 or before 2019. Kasi nasa ano to eh. This is published in the Scopus Journal. When he formulated this model, wala pang study na sabay yung tatlo. Mayroong study, hiwa-hiwalay. For example, Article 1 about transformational leadership and employee engagement. Next article investigated the effect of employee engagement on intention to quit. Then another set of articles, effect of leadership on intention to quit. During the time na nag-formulate siya ng ganyan, mediation model, wala pang study na nag-investigate about the three. Kaya he decided to conduct this model. Nagkataon na tatlong variables, mediation. So mediator ang employee engagement, dependent yung intention to quit, then independent yung transformational leadership. Okay? So kaya ang title niya, Mediating Effect of Employee Engagement on the Relationship of Transformational Leadership and Intention to Quit. Okay? So kaya yung hypothesis 1 niya is something about the link between transformational leadership and intention to quit. So if you look at the hypothesis 1, transformational leadership is negatively related to intention to quit. So saan siya nakakuha ng idea na negatively related to intention to quit? So sa mga previous studies na negative ang relationship between the two. Hypothesis 2, yung transformational leadership is positively related to employee engagement. So the link from leadership, transformational leadership to engagement, employee engagement, the relationship of that based on the literature is positive. Kaya gumamit siya ng terminology na positively related. Then his third hypothesis is the link between employee engagement and intention to quit. So there is a negative relationship between engagement of employees and intention to quit. So based on the literature. Tapos nagdagdag siya ng fourth hypothesis niya, something about mediation. Dahil nga nabuo yung triangle, so yung third hypothesis niya is that employee engagement mediates the relationship between transformational leadership and intention to quit. So there are four hypotheses for his paper, and this is published in the Asia Pacific Social Science Review, managed by LSU, and this journal is Scopus indexed journal. Okay, so another one, this is the paper that was released by the Journal of Education last July 17. We have plenty of variables. We have 8 variables in the model because we were using the extended technology acceptance model. So the extended technology acceptance model, nag-exist na yan. So the variables in that model are actual use of technology, behavioral intention to use, yan yung mga variables, attitude of the users, attitudes towards use of technology. Then there is also another, there are other variables such as perceived usefulness of the technology, perceived ease of use of technology, facilitating conditions, perceived self-efficacy, then we have system quality. So all of this are covered in the extended technology acceptance model. Matagal na yan nakapublish na ng yung model na yan. Kaya kung if your present study shall be anchored on an existing model na matagal ng acceptable model na, hindi ka na mahirapang mag-justify. Kaya mas maganda i-ano mo, anchor your present study to existing theory. So ang ginamit lang namin dito ay the model, then we tried to apply it to our learning management system. Kasi sa PNL, we have our own learning management system. Even before pa nangyari ang pandemic, mayroon na kaming online learning management system ang tawag. Naka-set up na yung aming, kaya pagdating ng pandemic, hindi kami nahirapan. Ngayong third term, continuous yung aming online classes. Okay. So in other words, we just use this extended technology acceptance model. We utilize this model, the variables in the model. We use that. Then we administer that to our instructors or professors who are using the LMS. Then we analyze. So we analyze using structural equation modeling. Yun lang ang ano dyan. We use different group of respondents kasi karamihan sa mga studies based on our literature sa ibang bansa, sa US, sa Europe. Dahil bago yung learning management system sa aming school, sa aming college. So na publish in the Scopus Journal. There is another one. We are 3 in the lineup, 3 authors. So still this is structural equation modeling. So this will be published in the journal, International Journal of Trade and Global Markets. It will be released in the first quarter of 2021. So ang tawag dito ay in-press. So waiting na siya. So the major variables here are three major variables. The first variable is the economic factor. This one, economic factor. Then the dependent variable is the international academic destination. So in other words, for example, country, asterisk country, ibig sabihin nun, choose university relative to program as their primary criterion of choosing an international academic destination. Basically, the respondents of this paper are international students. For this item, we asked the international students, graduate students, the reason of enrolling in the Philippines. What is their reason? Do they choose university as #1 criterion of choosing Philippines? Is it the name of the university relative to the program? Okay, so yun ba yung criteria nyo? University, pangalan ng university? So it's a yes or no actually. So yung country is a yes or no. Kung university ang, so kung country pala, country. So sorry. So yung asterisk country, choose country relative to program. So ang ibig sabihin, ang priority nila, primary criteria nila is yung country. Pangalawa na lang yung program. So yun yung ibig sabihin ng asterisk country. So it's a yes or no. Kasi doon sa questionnaire, pinapili namin kung country ba o yung program mismo. Yung program mismo, for example, business program. So kung pipiliin nila ang country as their primary criterion of choosing an international academic destination, iti-check nila yung country. Pero kung ang primary criterion nila ay university, iti-check nila yung university. Kaya mayroon tayong dalawang country and university. Okay? Then, yung decision-making process, there are 5 stages. Stage 1, in terms of decision-making process, there are 5 stages sa literature. In the literature of decision-making process, there are 5 stages. Stage 1, 2, 3, 4, and 5. Ibig sabihin, yung stage 1 affects stage 2, affects stage 3 up to stage 5. Sequential mediation yan, di ba? So yung stage 1 up to 5, mediators yan siya. Tapos yung economic, yan yung independent variable. Yung country is the dependent variable. So mediators ang decision-making process. Ang tawag sa 5 stages, stage 1 up to stage 5, ang tawag dyan ay decision-making process. Kaya ang title is decision-making process, a mediator of the relationship between economic factor and international academic destination. Pwede din kasi question na question yung title. Parang medyo catchy ba? So, ibig sabihin ang reader mag-isip. Oo nga no, ang mediator ba ang decision-making process? Pwede rin ang title mo, decision-making process as a mediator between economic factor and international academic destination. So it can be an interrogative statement, it can be a declarative statement. Okay, so we decided to use the interrogative statement. So it was accepted. So nag-submit kami nito is matagal na, 2018 pa. Pero na-accept ito by last year lang. This year lang. Early this year, January yata. Then we were informed that the paper shall be online or published by first quarter of 2021. Okay, so there are plenty of example. For example, here in the business, if the supplier's human capital walks away, where would the customer go? So the variables are structural capital, human capital, likelihood of following the K contact. Then the other variable is social capital. Then the paper includes the control variables. Okay, so mayroong control variable siya kagaya ng complex buying center, prior length, autonomous decision making. So napansin nyo, yung bawat path, for example, human capital going to likelihood of following the K contact, mayroong nakalagay na H1, tapos plus. Ibig sabihin, alam na ng author na mayroong positive relationship between human capital and likelihood of following the K contact. Alam niya na positive dahil sa mga studies na ni-review niya, positive ang relationship ng human capital and likelihood of following the K contact. Kaya nagkaroon siya ng H1. So the H1 states the higher the client perceives the K contact employee's human capital to be the greater the perceived likelihood that the client will follow the contact employee should the contact employee leave. So H2, ang H2 dito is the link from social capital to the likelihood of following the K contact. So this link, so nilagyan niya ng H2 then plus, meaning to say the literature review states that the social capital has a positive link with the likelihood of following the K contact. So the hypothesis is like that. The third is about moderation. Moderation, ang madaling maintindihan kung moderation dahil from a latent variable going to the line, nakakonect siya doon sa path. So from latent variable going to path. Okay? So ang ibig sabihin niyan sa H3, moderation rather. H5 also is moderation. Then H4 is direct effect of the structural path going to the likelihood of following the K contact. So H5 again is moderation. Okay, so we will have a separate discussion about moderation. So ang focus natin ngayon today is the effect of one latent variable on the other. Yun lang muna. At saka correlations. So another example is this variable. Ang ginamit niya dito is warp PLS. Malinaw na warp PLS dahil mayroong path coefficient plus the p-value. So kahapon I showed to you an example. Okay? So H1 niya is this link or this path. So we have the country and the involvement. Kaya yung H1 niya, individualism, is negatively related with the level of involvement of major suppliers in the production process. So H2, this link, then H3 is this link, then H4 is from face-to-face communication going to involvement. Then H5 is the link from face-to-face communication going to trust. Okay, then H6. So ganyan yung uso ngayon kung structural equation modeling ang gagamitin natin. So H6 is a statement relative to the effect of involvement on performance. Kaya yung H6 is the effect or the level of involvement of major suppliers in the production process is positively related with the relative marketing or market performance of the buyer firm. Then, of course, number 7. So the seventh hypothesis is about the level of trust. Level of trust with major suppliers is positively related with the relative market performance of the buyer firm. So this path. Okay? So yung dalawang extra variables ay wala na siyang hypothesis dyan. Okay, kasi ito ay ginawa niyang control variables, yung employee at saka sales. Okay, so ang tawag natin doon ay mga path analysis or structural equation modeling. Structural equation modeling dahil lahat ng mga variables na pansin nyo, ovals. So kapag ovals, ibig sabihin nun, latent variables. May mga items sa loob. For example, trust, so that you can measure trust, there are items within that. So that you can measure involvement, there are items in order to measure involvement. Diba yung mga latent variable tapos confirmatory factor analysis ang involved dyan. Then plus yung mga path, yung arrows, kaya combination of path and confirmatory factor analysis. Okay, there are two approaches. First is the component-based SEM. So component-based SEM, or also called partial least squares path modeling. So it is also called PLS. So partial least squares SEM. So there are plenty of names. Pwede siyang component-based SEM kung i-google mo yan. Pwede ring partial least squares path modeling. Pwede din na PLS. PLS stands for partial least squares. Then SEM, structural equation modeling. So it is a causal modeling approach. The aim of this approach is, for example, I will use the model. Satisfaction, ito yung ginamit natin kahapon. Satisfaction, then trust, then loyalty. So they are dependencies among the variables are reflected in the arrows. For example, loyalty is dependent on satisfaction and trust, while trust is dependent on satisfaction. Or we can say satisfaction and trust affect loyalty. Then satisfaction affects trust. Pwede ganun. Then we have the R-square, 0.63, indicating that the proportion of variance in loyalty explained by satisfaction and trust is 63%. Then the proportion of variance in trust explained by the only one predictor, satisfaction, is 0.49. So the goal of structural equation modeling using Pls Sem approach is to find the path coefficients such that the R-squares are maximum. Okay, so parang ganito. What are the coefficients of the model? What are the B coefficients of the model such that the R-squares are maximum? So it is something about calculus, right? However, the calculus problem, the solution of that derivative, then naka-embed na yan sa software. Kaya hindi na tayo mag-calculus. Pipindutin na lang natin yung software, then the software na ang bahala sa pag-compute. Ganyan yung first approach. Maximizing the R-square in the model. The second approach is different. Yung second approach, yun yung ating palaging binabanggit kahapon pa. From path analysis going to confirmatory. Di ba mayroon tayong, ma-recall natin yung chi-square. Yun yung pinaka-simple example. Sa chi-square analysis, mayroon tayong observed at saka expected. We gather the data, ang tawag natin doon ay observed. Then we have also the expected. So based on the model. So dito dahil multiple variables ito, multiple items, ang ano natin is sample covariance matrix. Ito yung observed. Kasi sample data ito. So sample data minus the theoretical data, we want that the difference should be minimum. Kaya magkaroon ka ng chi-square. Kasi ang chi-square, ang observed minus expected, the result of that should be minimum. So it is still a calculus problem because the problem is like this. Find the estimates of the model. Estimates of the model meaning to say yung mga path coefficients. What are the path coefficients of the model so that the sample data and the theoretical data, the difference of that is minimum. So ganon yun. Diba sabi ko kahapon at saka kaninang umaga, we have the data, then we fit it with the model. Then if there is consistency, so we accept the model. So ganon din dito, we have the sample covariance matrix. Yung sample data mo, if you fit mo sa theory, then we want that the difference of that is minimum. Ibig sabihin consistent kung minimum siya. Okay, so consistent siya kung your data and theory or your data and model are consistent if the difference is 0. Okay, or minimum. Yun yung dalawang approaches. So ang tanong kasi, which SEM approach to use? Do you use the covariance based? Ang tawag kasi doon sa kahapon, yung path analysis covariance based yun. Yung ating confirmatory factor analysis, covariance-based. Then, kaya mayroon tayong chi-square, di ba, kanina, as basis of our fit indices. Yung goodness of fit, may chi-square, mayroong p-value. Kaya covariance-based yun. Okay. So ang tanong, di ba dalawang approaches of ECM, which one is to be used? Hindi naman pwede sa isang paper mo, sa isang research article, hindi naman pwedeng dalawa ang gagamitin mo. You should choose covariance-based o yung PLS SEM. Okay? So we will answer the questions, which ECM approach to use. We will answer this in terms of research goals, in terms of measurement model specification, in terms of structural model, in terms of the characteristics of the data, in terms of model evaluation. So of course, hindi naman basta-basta mag-invento lang tayo ng sagot para dyan. So of course, we need to utilize the article of Hare and colleagues to answer the question. So only one question, pero it depends on the criterion. So in terms of research goal, mayroon. For example, if the research goal is theory development and prediction, you can utilize PLS SEM. Yung unang approach, yung i-maximize yung R-square. Okay? So, if the goal of the researcher is to test an existing theory, or you want to confirm the theory is already there, nag-exist na, and your goal is to confirm or test the theory or compare with the alternative theories, the best method is the covariance-based SEM. Okay? Yung AMOS, yun. Yun yung ginamit natin kanina. If your goal is exploratory or an extension of an existing structural theory, so the authors suggest that PLS SEM is the appropriate one. Okay, so theory testing at saka theory development. So, in terms of variables, kung mayroong formative latent variable. So, we discussed about formative yesterday and this morning. So, kung ang model mo mayroong formative constructs or formative latent variable as part of the model, then PLS SEM na yan. Okay? In case there are error terms. Di ba sa ating kaninang model mayroong error terms? Sometimes kasi yung error terms correlated din. So meaning to say you can correlate error 1 versus error 2. So kung kung mayroon kang ganun, so you can use the covariance-based CM. Okay, so another one is the complex in terms of structural model. For a complex model with many constructs, many indicators, meaning to say many items, many variables, so you can use the PLS SEM. Okay? In terms of sample size, for small sample size, okay, so we will discuss about sample size later. Pag-discuss na natin ang PLS SEM, we will discuss what is the small. Pag sinabi mong small sample size, what is small? How small is small? How large is large? So we will answer that question later on, tomorrow. Kasi bukas ay mag-ano tayo. Last topic natin in the afternoon is the Pls SEM. Okay. So here we have the large sample size. If it is large, then covariance-based SEM. However, we have a remark here na ang large sample size, for a large sample size, the two approaches or the results of the two approaches are similar, provided that the large number of indicators are used to measure the latent variable. Okay? So usually yung 200 plus, rule of thumb, 200, large na yun, large sample. Then in terms also of the normality distribution, normal distribution of the data, if the data are non-normal, do not use covariance-based SEM. Use the PLS. So there are other assumptions of covariance-based kasi parametric kasi yung covariance-based. Kagaya ng equal variances, ang tawag natin dyan homozygosity, yung normality assumption. So kung hindi ma-meet, then do not use covariance-based SEM. Ang gagamitin mo ay PLS SEM. Okay? So in terms of scores, sometimes the researcher wants to compute the scores of the latent variables because the researcher wants to use these scores for subsequent analysis. Halimbawa, gagamitin niya yung score to conduct t-test, to conduct ANOVA. So you can use PLS SEM. Kasi ang PLS SEM approach can compute the scores, while the covariance-based SEM cannot compute. Then we have the research requires global goodness of fit criteria. The global research criteria, yun yung chi-square. So, yung covariance-based kanina, di ba, kaninang umaga at saka kahapon, mayroong chi-square. Goodness of fit criteria, the global goodness of fit criteria, yun. Kaya magagawa lang yun ng covariance-based SEM, yung AMOS. Then if you want to further investigate kasi mayroon pang kasunod dyan sa ating confirmatory factor analysis. Ang tawag dyan ay measurement model invariance. So it's higher than confirmatory. So we can utilize the covariance-based SEM. The software for covariance-based SEM is AMOS. The software for PLS SEM is WARP PLS. Okay, so now I am almost done with the lecture part. So it's almost 3 o'clock. So here we have the covariance-based SEM. Again, we need a theory first before we can use the covariance-based SEM. Because this kind of structural equation modeling is a theory testing analytical technique, similar to confirmatory factor analysis. So again, the variables can be a mix of latent variables and observed variables. Like the path analysis, you should have your research model, or you call it conceptual model. The conceptual model or the research model shall be tested, or yan yung i-confirm mo. Kasi nga confirmatory technique ang covariance-based SEM. Your first requirement here is that you should have a research model. So kanina nagbanggit tayo ng simulacrum, the terminology of the University of Santo Tomas when it comes to conceptual diagram. Di ba pag sinabi mong conceptual framework, may diagram ka. Tapos yung diagram na yon, ang tawag nila doon ay simulacrum. Okay, so proposed theory represented by the research model is confirmed if the data, your gathered data and the structural equation model are statistically consistent. So kung parang ano lang din, ang concept niya ay parang sa path analysis at saka confirmatory factor analysis. Dapat acceptable yung goodness of fit. So kung hindi siya acceptable, of course, you need to modify the model. Okay. So I have here a sample. Okay, so I'm sure you are familiar of this variable. Satisfaction with physician service. Then the other one is the satisfaction with nursing service. Then we have the satisfaction with waiting time and the overall satisfaction. Dagdagan natin ang overall satisfaction. Kasi kanina tatlo lang yun. So ang hypothesis mo based on the literature, assuming that you conducted a literature about this, you found out that there are existing studies about physician service to satisfaction with waiting time, then from satisfaction with nursing service going to the overall satisfaction. Assuming na yan lang ang nabuo mong model, yung framework mo, yan ang nabuo mo after your intensive review of literature. So, malinaw yan. Ganyan ang setup natin sa college at saka sa graduate school. Mayroon tayong framework. Okay? So from that framework, of course, mayroon na tayong questionnaire. So we will create a questionnaire. We can adapt an existing or we can create our own. Then we gather the data. Then after the gathering of data, of course, iti-test na natin yon. So ito na yung resulta. So sa left side. So the result in the left side, pag titingnan mo yung chi-square, 204. Tapos ang p-value mo, maliit. Dapat kasi ang p-value niyan ay malaki. Okay? Greater than 0.05. Tapos ang RM is EA, or the root mean square error approximation, should be less than 0.08 para acceptable. So, hindi siya acceptable dahil 0.106 yan. Lalong hindi acceptable kung gamitin mo yung GFI. Kasi 9 to 8 lang. So, ang acceptable dyan is 0.95 or higher. The same also with AGFI, hindi siya acceptable. So, ibig sabihin, yung framework mo ay hindi nag-work. Your proposed theory na yung apat na variables are intercorrelated based on the arrows in the diagram. So, hindi nag-work. So, may kulang. Pero pag i-improve mo na, pag titingnan mo yung goodness of fit dito, okay, nagiging okay na. Pero dapat pala, yung waiting time, may arrow ka pointing to nursing service. May arrow ka rin from satisfaction to physician service going to the overall satisfaction. So, ibig sabihin, you can modify your proposed framework. Your proposed model, you can modify that and submit an alternative or improved model. So paano na ngayon yan? Mayroon kang proposed model na hindi nag-work. Then mayroon kang alternative model na better than the proposed model. So ang gagawin mo, of course, The suggestion here is that ang gagawin mo lang dyan ay i-present mo yung inyong present mo yung proposed model mo, kita mo yung goodness of fit na hindi siya acceptable. So indicating that your model and data are inconsistent. So it needs improvement. So because of that finding na hindi siya acceptable, hindi ka muna magbigay ng conclusion kung yung one variable affects the other. Huwag muna. You need to look for alternative models. The acceptable alternative model. So the acceptable model, yung may mga additional path, yan yung acceptable. Dito ang basis mo for your discussion. Okay. Ang tanong, paano natin i-present yan? So I have a list of steps on what to do. So of course, discuss the research model to be confirmed. So the discussion of that starts from the development of your conceptual framework. Kasi yung output ng literature review mo ay yung framework. Then prepare the research instrument. So when we say prepare, you can adapt an existing questionnaire or you can develop your own questionnaire. Then gather your data. Then third, prepare the data set, either Excel or SPSS. Then after that, fit your gathered data with your research model using ECM software. So example lang yung Amos kasi marami namang software. So if you're good in R software para makatipid ang university, so you can use R. Then you have to prepare the results of the research model, of course. Yung ano mo, conceptual framework mo. Then of course, I would like to highlight that your research framework is just a temporary model. Yun kasi ang tawag natin dyan ay research model. Temporary yan. Kaya nga, you have to investigate your model, you have to test. Kasi hindi pa yan final. Temporary yan. It can be wrong, it can be correct. So, kung wrong, i-correct mo. So, results of the alternative or improved models will be generated if possible. Kung possible lang naman na mayroong alternative, so kaya you have to perform, you have to investigate further the possible, you can look for the possible alternative model. Then you can present the results. So for the validity, for the results, you have to divide it into two. The first one is the measurement component. Kaya nga lagi nag-umpisa tayo sa measurement component because we have the convergent validity, the discriminant validity, and the reliability. Tawag natin dyan ay measurement component. Then, after the presentation of the measurement component, again, pag sinabi natin measurement component, that includes the validity and reliability of our variables. Isang section yan doon sa results mo. Then, goodness of fit and fit indices, that's another section. Showing the goodness of fit and fit indices of the model and the alternative models. Then, the next one is the structural component. Structural component meaning to say yung effect ng one variable on the other, yan yung structural component. Kasi kung valid and reliable na yung mga variables mo, Ang next dyan ay yung effect naman. Kasi kung hindi siya valid, useless lang yung pag-investigate about effect. So your structural component should composed of tables and diagrams with estimates. If research model is not acceptable, present only the diagram with estimates. The statistical tables can be put in the appendix section. If there is alternative model, then present the diagram with estimates as well as the statistical table. There can be more than one alternative models. So present the best alternative model. Then, of course, you have to write a separate section that contains the discussion of your proposed model. So dapat mayroon kang intensive discussion about your proposed model. So it's a separate section. Yung ano kasi, yung structural component na part, para lang yan masagot yung hypothesis mo eh. Diba sa research mo may hypothesis ka kung whether X variable affects the other. So masasagot mo dyan sa structural component. Pero yung model, yung alternative model, masasagot mo dito sa separate section. Kung bakit nag-propose ka ng alternative. So that is the content of your separate section, discussion of your proposed model, your alternative model. So we will have an example about it. So when it comes to measurement component of the model, we can present the convergent like this. Convergent validity, alam na natin ang kapag convergent validity, it includes the indicator loadings as well as the average variance is extracted. Then we can also present the discriminant validity. Diba? So, mayroon ka ng convergent, mayroon ka ng discriminant. Then mayroon ka ring discriminant validity based on Fcmt. Kaso yung Fcmt, ma-produce natin yan using Amos version 26 or higher. Then we can also have this reliability coefficient. So in other words, present the convergent validity, discriminant validity, as well as the reliability coefficients. Then after that, present also the goodness of fit and fit indices. So in my example, I provided model 2. Okay, model 1, we present the goodness of fit of model 1, then goodness of fit for model 2. Okay, so ang model 1 na tinutukoy natin dyan ay yung this one at the left side. Yun yung model 1 mo. Dahil nag-modify ka, this is your model 2. Okay, so I'll go back to the next one. So this is, we have the model 1 and model 2, goodness of fit. So later on, I will show to you the result using Amos. Okay, using Amos later. Then, of course, model 2 is much better. Model 2 is better than model 1 when it comes to goodness of fit or fit indices such as GFI, AGFI, CFI, NFI, EIC, ECVI. Always model 2 is better. So model 2 is your final model alternative. Okay, so this is the diagram of your model based on the framework. Kasi ang framework, ganyan lang, naka-triangle lang siya, di ba? Doon sa framework natin. So naka-diagram lang. So your I mean the this diagram is based on the framework. Ang sinabi kasi sa framework, physician service affects waiting time. Then nursing service affects overall satisfaction. Then satisfaction and nursing service affects overall satisfaction. Yun lang kasi ang sinabi doon sa framework mo. Yun yung na-review mo. Review of the literature. However, this model 1, hindi siya nag-fit statistically. Kaya nag-modify ka. So your modified model is this one. So remember that the path from waiting time going to nursing service at saka physician service to the overall, hindi yan kasama sa framework mo kanina. Kaya naglagay ka dito ng additional path. Diba? Mayroon kang additional path. So the additional path is basically the suggested significant path. Okay? Suggested significant path. Yan yun. Then yung first four are your hypothesis. Kung dissertation man yan, yung 4 na yan, yun yung hypothesis mo. Yung additional path, hindi yan kasama sa hypothesis mo. Nadagdag lang yan after intensive investigation of your model using your data. Then, of course, you emphasize in your discussion that the research model is not acceptable. So the researcher decided to modify the model. So the modified model or the alternative model is at the right side. Ito na yung i-propose mo. Hindi na yung framework mo. So ito na yon. Kasi nga yung ano natin, yung conceptual framework natin ay temporary lang yun. Hindi yun ang tamang model. Based on the results, based on our foregoing results, yung framework natin, ito ay wrong. We need to use this model. This research model is the best one or the alternative one. Okay. So meaning to say, there is an additional component in the model. That additional component is the path from this oval going to the other oval. Then the path from physician service going to the overall satisfaction. So in other words, your paper consists of answers to the hypothesis plus the additional path. Yan yung contribution mo sa paper mo. Okay, so I will present to you how to make or how to execute that in AMOS. So I will go out from the slides. I will proceed to the AMOS. So I will go back to the AMOS again. So earlier, we tried to conduct a CFA. Pwede natin gagamitin yung drawing na yan. So we can save this. Okay. So we click save or file, then save as. So at this time, PUP is CM1. Okay. So that would be our file name. Then of course, we will remove the arrows, the correlations. Then we will rotate the physician service. We will move physician service up. Then pwede siguro ilagay natin dito sa baba. So upward. Then nursing service might be rotated also. Something like that. Then move it using cart. Move it here. Okay. Then waiting time, we can rotate it. We can put it above. So here. Okay. Then after this, we need the arrows. So based on our framework, physician service affects waiting time. This is our hypothesis number 1. Then hypothesis number 2, physician service affects nursing service. Then there is a fourth variable. The fourth variable is about the overall satisfaction. So it is an oval. So the oval consists of 2 items. So the items, ito. So 1, 2. O, di ba? Then i-rotate mo using this rotator. Go back to the oval, then i-click mo lang. Ikot na yan siya. Then you can click the cart para mausad. Ganyan. Then, of course, if you click the list of items or list of variables, list of indicators, gumamit tayo ng OS1 and OS2. Worth the money and would recommend. That is for the overall satisfaction. So the overall satisfaction, ito. So we can put a label for this. Right click, then object properties. Then overall satisfaction, OS. Then pwede naman natin lagyan ng label, overall. Then satisfaction. Okay. So hindi kasya, so we can change the font size para consistent tayo, 14. So yan ang font size natin kanina. So overall satisfaction. Okay, so we need additional information. For example, OS1, OS2. So lagay lang natin yan dito sa box. Point the cursor on the box, right click, then object properties. Type OS1. Then type OS2. OS2. Okay. Later natin ayusin yung font. Then, after that, we can draw another arrow. Okay, so ito exactly yung framework. Okay, so this is exactly the framework. You have only 4 paths. Okay, so yan yung framework mo. Then, of course, waiting time now has effect. So dapat mayroon kang additional error, prediction, error in prediction. So we can put another circle here. We can put another circle here. Bakit naglagay tayo ng additional circle dyan? Dahil if we predict waiting time, hindi lang naman ang physician service as your predictor. There are other predictors of waiting time, pero naka-embed yan dito sa error term. Okay. Overall satisfaction, hindi lang naman waiting time at saka nursing service ang mayroong effect dito sa satisfaction. So there is error in prediction. Nandito na yan sa oval. Then, ganon din sa nursing service. So para mabilis ang paglagay ng label sa mga error in prediction, you can click plugins, then name unobserved variables. So automatic naglagay siya ng error term, di ba? Okay. So after this, of course, we can save our model. Sorry. So dapat siya save. File, then save. Okay. So ready na tayo for our computation. So itong physician service, by the way, wala tayong error in prediction kasi hindi naman siya endogenous variable. Wala namang nakatutok na arrow para sa kanya. So we don't predict physician service. Ang mayroon lang error in prediction ay yung waiting time, overall satisfaction, and nursing service. Kasi may arrow na nakapoint sa kanila. So we are now ready for the computation. So ang computation, of course, before you go to the computation, check muna natin kung tama ba yung ating specification ng mga variables. For example, lahat ng error terms mayroong coefficient na 1. So, perfect, okay. Ang next na titingnan natin, dapat one of the indicators per latent variable should have a regression weight of 1. So, for the nursing service, mayroong 1 na coefficient. For the physician service, mayroong 1 na coefficient. For the overall satisfaction, mayroong 1 na coefficient. For the waiting time, mayroong 1 na coefficient. So, perfect na tayo doon. The next thing to check is the error in prediction. The coefficient should be 1. So, this is the error in prediction. We have 1. We have also 1 as coefficient. We have also 1 as coefficient. So, perfect. Okay na siya. So, we can now proceed to the calculation. So, we have analyze, then calculate estimates. Just click. So, in just a matter of seconds, nagiging red arrow na yan. So, if you click that red arrow, the coefficients will appear on your screen. So, nakita natin na sa bawat path coefficient, mayroon tayong, sa bawat path pala, mayroong coefficient. 0.80, 0.79, 0.44, 0.62. Okay? Then, sa bawat arrow from the oval to the indicator, mayroon siyang indicator loading. 0.90, 0.95, 0.93. Ang tawag natin dyan na indicator loading because we set it as standardized estimates. Okay? So all indicator loadings are acceptable, greater than 0.50. Okay? However, if you look at the chi-square, 204, ang kanyang root mean square error approximation is 0.106. Ang pinakamababa dito is 0.08 kasi. Pinaka cut off, 0.08 or below dapat. Okay? So hindi siya acceptable. So ngayon, hindi siya acceptable pala ito. Meaning to say your proposed model based on your framework is not working. Your proposed theory, hindi siya nag-work dahil hindi naman acceptable yung fit indices. So if you look at the text output, you click view, then you click text output. So if you click estimates, so it looks good. Looks good dahil ang p-value mo less than 0.00. So meaning to say 0.001, less than 0.001. Meaning to say the path from say for example physician service going to overall satisfaction, Dito, physician service going to waiting time, for example. Physician service going to physician waiting time, the coefficient is 0.909. So I will show to you the screen for the diagram para malinaw. Split natin ang screen. Okay, so this is your diagram. So you can move it to the left. Then liitan natin ng konti para magkasya. So ganyan. So di ba mayroon tayong PS, physician service, ito yon, physician service going to waiting time, going to WT. So ang nakalagay doon sa kung i-unstandardize natin yan para consistent, so ang coefficient natin is 0.90. 1. Dito naman 0.99. 0.909. So if you round off this, so it is 0.91. So dito naman sa physician service going to nursing service, PS to NS, 0.77. Oh, diba? Dito yung 0.77. Then from WT going to OS, 0.63. So ito yun. Then from NS, nursing service, going to OS, 0.51. So ito yun, 0.514. Lahat na yan ay statistically significant because the p-values are all smaller than 0.05. Kasi yung tatlong asterisk, ibig sabihin nun, less than 0.001. Okay? So mayroong significant effect. Lahat ng arrow na nandyan, mayroong significant effect. However, the goodness of fit looks, it seems that the goodness of fit implies that we need to improve the fit of the model. So we need to improve, meaning to say we can modify further the model. So yan yung ating model based on the framework. So save natin yan. So we will use this model. We start from here, then we create our alternative. So we save as. So we will save as. So we will have an alternative. So this is alternative to the model. So we call it alternative, right? So as researcher, how do we know that what shall we do in order to decide alin dyan ang babaguhin? Yun yung next na question dyan. So ang gagawin natin, we visit again our analysis properties. So you view analysis properties. Then we compute the, we click the output. Then we request the modification index. Parang kagaya sa ginawa natin sa path analysis yesterday. We requested the modification index yesterday to improve the model. Okay? So, labas tayo dyan, then analyze, then calculate estimates again. Okay? So, in our text output, click mo yung view, then click text output para lalabas yung text output dito. Then, kasama na dyan yung modification index na folder. I-click mo yung modification indices. So, nandyan na yung suggestion ng software. So, for example, if you click the plus, so may suggestion ng software in terms of covariance, may suggestion ng software in terms of variances, may suggestion ng software in terms of regression weights. So, sa regression weights, So sabi ng software, kapag i-connect mo yung nursing service with waiting time, mayroong reduction ang chi-square ng 35.517. So nursing service going to waiting time. Then if you draw also a line from waiting time going to nursing service, waiting time to nursing service, so there is a change of 31. Okay? So, mamimili tayo kung alin dyan ang ano natin. For example, we follow the 35 from nursing service going to waiting time. So, we go back to our model dito. Sabi ng model, dapat daw we draw a line from nursing service going to waiting time. So, ang chi-square niyan ay mag-improve daw, sabi. Okay? Then calculate. Analyze, then calculate estimates. So, what will happen to our chi-square? Kanina, 410 yung chi-square. Ngayon, nagiging 73 na lang. Kasi mayroong reduction. Okay, ulitin ko. I will remove the path. If I compute, analyze, then calculate estimates. So the chi-square now is 204 pala. 204, tapos yung root mean square error approximation mo ay greater than 0.08. So we don't like na mayroong root mean square error approximation na greater than 0.08. So hindi yan siya maganda. So ngayon, we decided to follow the instruction of the software that we need to draw a line from nursing service going to waiting time. Okay, then click calculate estimates. Or we can click this analyze, then calculate estimates. Okay, then after that, we have a new model na mayroon ng path from nursing service going to waiting time. So, yung root mean square error approximation natin ay nag-improve. Actually, lahat ng, say for example, root mean square error approximation, the GFI, the CFI, nag-improve na. So, meaning to say, this is another alternative model. Okay, so if you visit again the text output view, then text output, titingnan mo ulit yung modification index. Tingnan mo kung ano ang suggestion niya in terms of regression weights. Ang suggestion niya ay nawala na, di ba? Kasi ito item level na lang yan eh. Okay? So there's no more suggestion. The software no longer suggests. So yung inyong final model might be this model. So nursing service going to waiting time. So that might be your alternative model. Okay, so in other words, you have the capability to modify your model. Just for example, if you add when you add the question is how do you know? How did you know that this is the right path? So i-run mo lang, analyze, then calculate. Then if you run, hindi siya acceptable yung goodness of fit. Then go to the text output view, then click mo yung text output, then look for the modification index folder. Mayroong plus dyan, i-click mo yung plus sign, go to the regression. So may naka-suggest dito na if you draw a line from NS, nursing service going to waiting time, your chi-square will decrease by 35.517. If you draw a line from waiting time going to nursing service, parang reverse line, mag-change ang chi-square ng 31. So kung ito ang susundin natin, whichever is the correct, yung may sense, yun ang susundin mo. Kasi pwede kasi ang line pala from waiting time going to the nursing service. Parang pabaliktad ang direction. So again, parang ganito yung arrow. From waiting time going to nursing service. So yan ba yung may sense o yung kanina? So if we follow this instruction if we follow this suggestion by Amos, kung i-calculate mo, ang p-value mo ay yung root mean square error approximation mo ay still acceptable. So ngayon, mag-isip tayong researcher kung alin ba dyan ang may sense. Is it waiting time going to nursing service o nursing service going to waiting time? So that is the work of, that is already the homework of the researcher. Kung alin dyan ang mayroong sense. Of course, the statistician cannot handle that. Kasi ang statistician nag-compute, nag-analyze lang doon sa results. So the final say is the researcher. Is it this arrow or the other way? Kung other way, so dapat i-check mo yung theory kung alin dyan ang tama. So i-calculate mo, acceptable din. Di ba? Acceptable din. So alin dyan pala ang tama. So it's up to the researcher kung alin dyan ang tama. Okay. So that's I think I am done with my discussion about structural equation modeling. So we still have time, so we can spend our remaining time for the question. I will answer your questions if you have questions. So I